Hello, hello, Shagat Unknown here. Welcome to another coding stream, another Rust coding stream here on the 14th of September 2022, local time 1725. I'm shocked that didn't change on me. This is the second time I have done that intro because the first time I forgot to start the stream. But that's about as far as I made it, so it's good. Okay, yeah, so last time I did a bit of a tutorial on building an ECS, an entity component system, and that's one of many things that are going to push me forward in my game development aspirations. So the next thing I said that I was going to do, and what we're going to be working on today, is a roguelike tutorial with libtcod. And I'm once again going to be following an existing tutorial, so I'm not trying to claim credit for this, but it is going to be a chance. I have done this one before years ago, but this is going to represent a chance for me to refresh on some of the things that I did here and just see what happens. And then I'm going to be going to something that looks like a way more advanced roguelike tutorial after I finish this one. So this will probably take 2 to 3 streams, I imagine, if not more. I would say probably 4 max, but I think I did most of it in a day when I did this before on my own, like 2.5 years ago. I think I did most of it in like a morning or something, so it wasn't too bad. But you know, talking over it'll make it take a little bit longer. So without wasting any time, let's go ahead and click on over to the browser here, and let's just start reading and delving into this a little bit. So again, full credit to Tomas Sedovic. Tomas, and we have an email address there. Czech, I assume. A roguelike tutorial in Rust plus tcod. So I was here at libtcod, and we actually see libtcod right here. So yeah, whatever. Hello, yeah, short introduction. Welcome. Hello. This tutorial will show you how to write a roguelike in the Rust programming language in the libtcod library. It is based on the Python libtcod tutorial. Getting familiar with Rust is not necessarily as easy as with Python. So if you've never programmed before, you may want to check out the original instead. That said, Rust is a fine language to start with. This tutorial does assume some prior programming knowledge and at least basic familiarity with Rust. However, we do talk about potentially foreign concepts when we introduce them, so you should still be able to follow along even if you don't have a lot of programming experience. There are 2 great resources to get started with Rust: the Rust Programming Language book and Rust by Example. You can find the source of this text as well as the code samples here. Okay, I'll just open that as a potential reference for later. Rust is a systems programming language targeting, why Rust? Rust is a systems programming language targeting roughly the same space as C++. That means it's fast and is generally used for things where you need a fair bit of control over how things are structured in memory, etc. Rust is a good candidate for writing a browser, database, operating system, web server, and games. What attracted me personally to Rust was the fact that it was reasonably low level, i.e. I could use it for things where I'd normally go for C or C++, with good support for calling into libraries in C and C++, written in C and C++, but feeling much more modern. It has a real module system, closures, powerful macros, and it protects you from seg faults. As a wonderful cherry on top, it doesn't have null pointers or references. I mean, it does have references, but maybe you mean null references. I think that may be what they mean. It's like references are all over. That's the ampersand. Why libtcod? Libtcod is a library specifically designed for writing roguelikes. It deals with rendering ASCII characters in a grid, mouse and keyboard input, and provides useful utilities for pathfinding and field of view, a noise toolkit, and a name generator. In other words, it provides a good chunk of what a typical roguelike would need. Among the alternatives to libtcod are T-Engine. The engine tome, Tales of Majayal, is written in, and Rot.js, a JavaScript engine inspired by libtcod for targeting the web. Tales of Majayal is a very fun roguelike. Anyway, so some notes about this port. Python and Rust are very different languages. That means what is sometimes straightforward in one may not be as easy in the other. The tutorial follows the structure of the original but changes things around where it makes sense. No global variables. Changing a global variable in Rust is not safe, and it's rather cumbersome too. We do use global constants for things like the world size, but instead of global variables, we just pass values as function parameters. No garbage collection and back references. Every value in Python is behind a reference counted pointer. The original tutorial contains a list of objects that are then moved around at will, e.g. by adding them into the inventory, without affecting the original array. They contain other objects components with back references that can manipulate the original object. Such a thing is in general not safe in Rust, and while you can use mutable reference counted pointers, the code becomes cumbersome and even then has limitations the Python version doesn't. To deal with this, we are using a contiguous block of memory, Vec, which holds the game objects directly, and we use references into that vector where necessary. So this is interesting to read this right now. 2.5 years on, where I actually have much more experience with Rust, because even reading this, I have a much better understanding of a lot of the things that they're actually saying here. I was still pretty new at Rust back in 2020, the start of 2020. That's when I really started delving into it, was 2020. All in one file. The original Python tutorial is all one file. That's not something you want to end up with, especially when you're collaborating on the project, but the final result is still not that big, and it makes writing and following the tutorial easier when you don't have to worry about where each code snippet goes. Architecture. This isn't trying to show the best architecture for roguelikes. It's an architecture that works. It's not the most performant or extensible one, but it's easy enough to follow and use to make more stuff. Sameness. The original Python tutorial is a bit infamous because games that people do after going through it all look samey. That's not a reason to shun the tutorial though. Just don't get caught in the game design of it. The purpose of this is to teach you how to write a game using libtcod. There's little of game design here. What I'd recommend is go through this, absorb the concepts, but then start from scratch when actually writing your own game and think about how to make it unique. So that's going to involve things like the UI and the way we actually display things. That's a big part of what they mean by that. If you took the exact code here and just ripped out like the items and stuff and like changed the theme of it, it would still look very samey. I think that's what they're trying to say here. So let's start the tutorial with part 1, graphics. Start your game right away by setting up the screen, printing the stereotypical @ character and moving it around with the arrow keys. This should be straightforward enough. Let's go on and check it out. Installing Rust, we already got that. Creating the roguelike project, I've already done that as well. Easy enough, and I've got mine open in VS Code, so that's cool. And I don't know if I want to just skim through this or not. Like main.rs is the file that contains your program. In it must be a function called main, which will be executed when you run your program. Like we already know this at the point where I'm at, but I guess there could be a viewer who finds this on YouTube or something that maybe just like, hey, this seems interesting. So for that sake, for that person's sake, I'll go ahead and kind of go through everything here, take my time a little bit. So in order to, although I'm not really going to go over installing Rust. I mean, it literally just links to the Rust homepage. So you can do that. Creating the roguelike project. So the way you make a new project in Rust is cargo new, and you can omit --bin if you're making a binary. It defaults to bin, but if you're making a library, you do have to put lib. So my only difference is I just did cargo new, and then I called mine something different. I called mine Coding Stream 8, whatever it is. Coding Stream 8 roguelike tutorial with libtcod. This here is just the name of your project, right? So then I cd into that directory, and I open that directory up with VS Code by doing code space dot enter. Boom, it opens up in VS Code. It's fun stuff. So this will create, so doing this cargo new creates 2 files, cargo.toml and main.rs. Cargo.toml contains metadata for the project and any dependencies you're going to need, such as libtcod. And main.rs is the file that contains your program. And it must be a function called main, which will be executed when you run your program. Cargo has automatically put a hello world program in your main.rs. Sorry, my eye's bothering me. it looks like this. And here we are. So mine's a little bit different. You could see there that I have a hello and goodbye world, and I initialized a logger, and you can see at the bottom there that I've already ran it. But I mean, it's really the same thing. No real difference between what's here. We got a FN main and a little bit of code inside of it. That's all. And the big difference is that my code, it does do something different. It returns an OK at the end, and then main itself returns result with just an empty tuple. I forget what they call it, the unit type. And then the error is the anyhow error type. So I've pulled in the anyhow crate, and we make the logger. Because I'm returning a result from main, I can use this question mark to basically just bubble up and fail if we can't make the logger, because I'm okay with doing that. We'll see if that conflicts with the tutorial in any way. Not sure yet. If they change main signature or anything. So yeah, you can run the code by doing cargo run release. So by default, you're not running in release mode, you're running in debug mode. So what you'll see me doing is you'll see me doing cargo run. But if I do cargo run release, you'll notice it'll be slower because it's going to have to build now. Oh, whoops, my bad. Well, you saw a moment of it. I did cargo run there, and it's 0.02 seconds because it was already built. And then cargo run release had to recompile everything in release mode, which optimizes it. And so it took 3.5 seconds, and then it ran again, and we're happy. Go. So yeah, we do cargo run release, whatever we want, and we get our output. We're happy. Rust will first compile main.rs and any other files it needs. There are none yet. The resulting binary program will be called Roguelike and placed in the target release directory. Mine's going to be a little bit different because the name Roguelike comes from what they called their project here with Cargo News, so mine's going to be a little different, but yeah, same idea. Cargo will then run the program, which will print Hello World. Rust and Cargo can compile programs in two modes, with optimization and without. Code compiled without optimizations is really slow, but it's easier to work with under a debugger. We'll be using the optimized mode in the tutorial with the release option to make sure no one is making speed claims without optimizations. If you do need the debug build for something, just drop the release flag. There we go. Adding libtcod. You must then install the dependencies for tcod, the Rust bindings for libtcod. Go to the following link and follow the instructions for your platform. Maybe I should have done... I thought it was just a dependency. But we might be fine, though. Let's open both of these. Okay, so we'll look at the instructions here. How to use it. Actually, there may not be any problems. It may be able to do this all on its own. How to use it. It depends on libtcod, so you need to build or download the official version. The libtcod version known to work is bundled with tcod sys, and Cargo will build it for you. But you need to build the dependencies installed. Alternatively, you can provide the precompiled libtcod library to override the building process. See below. Yeah, so might have to fight with this for a moment, which sucks. Or we could do that, we could do this. By default, tcod rs will build the library statically on Linux. Yeah, we want to do that on Windows. We'll work with it as we go. We'll see how much setup I need to do. tcod sys is what I'm interested in. libtcod version known to work is bundled with tcod sys. Okay. We'll take a look at it in a minute. Adding the font file, we'll be using this Arial 10x10.png that ships with libtcod. You can download it from here. Feel free to check out the other fonts in there and pick the one you like. Be sure to put it in your game directory next to cargo.toml. Okay. So let's do that. Okay. Repositories. You don't see this, but it's okay. We'll drop it in the top level, and then I can move it around as needed. So they say, where did they say to drop it? Be sure to put it in your game directory next to cargo.toml. That should be fine. So let's click back over, and yeah, you can see Arial 10x10.png there on the left-hand side is right next to cargo.toml. It's in the same directory, so we are good there. Okay. Now the next step, showing the on screen. To use any external library, i.e. code outside of your project in Rust, you need to have it in cargo.toml under dependencies. So we're going to do tcod equals 0.15. Let's go ahead and put that into cargo.toml. Boom. That's really still the newest version. They did say it's unmaintained, so I guess that makes sense. Now we'll see if it complains or if it's able to build this thing on its own or what. A little confused by what it was saying, and I didn't want to delve into it anymore yet, because we'll see what happens. Rust libraries are called crates. Next, add some imports via the use statements. So we're going to use tcod colors and tcod console, and we're just going to do the star, which says get everything from those. It's a wildcard. So normally I'm not going to be copy pasting, but in this case, it's really simple. I'm just going to go ahead and do that. Okay, now let's go back over. Like in Python, Rust code can be structured under modules. We could always use the full path to a particular function or type, e.g. tcod console root. But with the use statement, we can bring it up to the current scope. So use tcod console root will let us type root directly, using the asterisk as the name means to import everything under tcod console, which means root, font type, background flag, etc. Now we'll add some constants so we don't end up littering the source code with a bunch of opaque numbers. So let's click on over and do that. So right up here, actual size of the window, and it's going to be const screen width I32 equals 80 and screen height equals 50. Const limit FPS I32 equal 20 frames per second maximum. Okay. Simple enough. We're not doing anything with the data yet. Just like in Python, constants are written using uppercase as a convention, not a hard rule. Unlike Python, the const keyword guarantees that they will not be changed. As you can see, constants need to have their type specified. In this case, it's I32, or a 32-bit signed integer. Rust is able to infer most types, but they do need to be explicitly mentioned in function definitions and constants. We will also encapsulate all of our libtcod-related values into a single Rust struct tcod root. Okay, so let's go ahead and do that. Struct tcod root. Alrighty. Simple. I like simple. It only has a single value right now, but we'll add more later on. Having all the tcod stuff in one place makes it easier to pass it around to functions, and doing it now will save us from gnarly refactors later. The Rust compiler would help us there, but it's still an annoying chore we can avoid. And now we can dive into the body of the main function and replace the printline macro with code that sets up the libtcod window and renders a character on it. To create a window, we call root initializer, and then there's a bunch of dots. So okay, they explain it. Yeah, ... init. In between go custom settings. Default values are going to be used for any option that's not specified, right? So we do an initializer, and then we set the font type, the size, the title, and then we do a .init once everything is ready. So this uses something called a builder pattern. Roughly speaking, it should be the builder pattern. So we'll take a look at it. Let me get that code here in the in our main function. So we're going to say let root equal root initializer, and then we're going to do .font Arial 10 by 10 .ping font layout tcod. We're going to do font type, and it takes a font type with the grayscale, size, screen width, and then height. Title, and they say Rust libtcod tutorial. So I don't see any reason not to go with that. .init. So if we take a look, they're probably going to break it down a little bit, but this initializer function here returns something called a root initializer. And then the font returns a mutable reference to a root initializer. Font type does as well. Every single one of these returns a mutable reference to a root initializer. And then eventually we can call init, which actually gives us back a root. So this is the idea of the builder pattern, where you keep returning these like mutable references to some kind of a builder thing, in this case a root initializer, and then ultimately you say build that thing now. So what you're doing is it's like specifying parts of a recipe and saying I want a font type, I want a size, I want a title, and then init is like the build function where it says, all right, you got all that now, make it, right? And so we got it back now, and we got it on root. So yeah, we're gonna unpack it here on the tutorial as well. So a bunch of stuff is happening here, so let's unpack this. Rust uses let to create new variables. So let root equal value will create a new variable called root. Variables are immutable by default, so they can't be changed accidentally. But we will want to change the root console, e.g. by writing characters to it. So to do that, we need the mute keyword. I actually left one thing out, so let's add that real quick. We need to make a tcod as well. So let mute tcod equal tcod. There's a shorthand here that is kind of nice. Normally when you make a struct, you would say root, it would be more like you have another variable called ASDF and you're assigning it to root. But if they share the same name, like I can't just put ASDF here, right? And it's like there's no field called ASDF. But if they both share the same name, you can actually just omit this first part where you're specifying the name of the field, and it's smart enough to just figure it out. Okay. So yeah, so we want to change the root console by writing characters to it. To do that, we need the mute keyword. So we make the tcod mutable, and then we hand root into it. Okay. So let mute tcod equal value means create a variable called tcod that we can change later. As you can see, we don't have to specify the type of the variable. Rust will figure it out. If we wanted, we could type it explicitly though. And then it's right here, let root, and then you do the call in there, type the actual type, and then you say equal root initializer, blah, blah, blah. Now let's have a look at the window options we're passing in. First, we're setting up a font. libtcod uses bitmap fonts of various formats. Calling the font methods lets us set our own font using a file name and a font layout. Font type is another option for loading a font. The font must be in the root of your project next to cargo.toml. If you've picked a different font than Arial 10 by 10.png, make sure to put the right file name in your font method call. Next, we set the window dimensions, width and height in characters, and the text displayed in the Windows title bar. Calling init will finalize the configuration and actually create the window. All right, so yeah, tcod system set FPS. That one wasn't up here. No, okay. So we're going to add another line. Let's just do that. tcod system, oops, system set FPS. Limit FPS. I guess it's fine to do that when we did it. Yeah, we should be fine. Okay. This line will limit the max number of frames per second libtcod will issue. This is useful when you have a real-time game loop. If you block for input, i.e. nothing happens until the player presses a key, it will have no effect. And speaking of game loops, now's the time to add one. Let's render a white @ on the screen until the libtcod window gets closed. Well, let's do that. All right, so yeah, your game loop is just an infinite while loop. Also, my indentation got wonky. It's better. All right, while not tcod.root.window closed. tcod.root.set default foreground white. tcod.root.clear. tcod.root.putChar. 1 1. The glyph is going to be this, and we need a background flag. None. tcod.root.flush. tcod.root.wait for key press true. Okay, we're going to break all this down in a moment in the tutorial, so I'm not going to bother talking about that at the moment. On my own, I think this is going to explain it clearly enough. Since we've set the FPS limit, this loop will be executed 20 times a second, no more. The window closed method on the root console returns true, this right here, returns true if the window was closed and false otherwise. We want to keep going while it's open, so we have to use not to negate the value. The next line sets a default foreground color to white. This is the color everything will be drawn with unless specified otherwise. The tcod colors module contains values for common colors as well as the color struct that lets you use your own. Then we clear the console of anything that we drew on the previous frame. That was this. Next, we draw the @ character at the coordinates 1, 1 on the screen. The 0, 0 coordinates the top left corner of the window. Using the background flag none says to ignore the default background color. Calling flush will draw everything on the window at once. And finally, we also need to call wait for key press, even though we're not pressing keyboard input yet. This is because libtcod handles a Windows manager's events, including your request to close the window, in the input processing code. If we didn't call it, window close would not work properly and the game would crash or hang. You can now run it and bask in your creation. So let's see if this is good or if I'm gonna have to fight with to get it to build. It's gonna be like, yeah, I can't link to tcod. I don't know. Yeah, tcod sys is working. Yep, I didn't have to do anything. Perfect. So yeah, don't get too caught up in how to get tcod working. It should build it on its own. Awesome. And there we have a little @ sign. Let me get that captured for you so you can see it. What's it called? Let me find it. Let me find it and then I'll get it captured for you. Where is it? All right, let me try something real quick here. Let me switch scenes for a second. I should have done this ahead of time, but I didn't want to start writing code. There it is. Cool. So now we've got it captured, and there it is. It's way larger here on the stream than it is on my screen. On my screen, it's what was it, 800, or no, it was 80 by 50. That's larger than 80 by 50, I feel like. Whatever, though, it doesn't matter. We're all good. We're all good here. Oh, it's weird. Okay. Anyway, close that. We're back here. Boom. See our goodbye world printing. Everything works. Perfect. Easy. We made a game, right? All right. So yeah, we'll look at input next, the complete code. We don't need to really look at the complete code so far, but it's helpful if you're doing this and you're a new programmer or something and you're struggling. It's helpful to be able to reference it. I don't think I had to reference anything that early the first time I did this, but I can be very picky about making sure my code is exactly like theirs. So even if my code works, I want all my spacing and everything to be the same. Sometimes I'll just literally copy it over mine. Because then in like future lessons, sometimes it's like, that's not what mine looks like, and it gets confusing. So maybe there's something to that. Also, I think later on we're going to be talking about closures and stuff, and I had not used them before. This, again, was when I was still pretty new at Rust, and I think that's where I was like, I got it working just based on what they had on the screen, but it definitely helped to have extra references at that point, because I was like, closures are weird. What's this, like, capturing state and everything that they're talking about? It's weird. But yeah, we'll get to that later. Maybe today, though. Probably today. I'll try and knock out like at least 4 of these chapters, but it's going to take a little bit. And then it's like a 12 chapter thing, so we'll see if I can do like 5 maybe. Okay, moving around. So that was cool. Now let's make our at move. We'll need to keep track of the player's position. Let's create variables for X and Y and put them right before the game loop. Okay, let mute player X and Y. Easy enough. Let's do that. There's our game loop. So we'll just let mute player X equals screen width over 2. Let mute player Y equals screen width or height over 2. Oops. Okay, now we're going to be using these momentarily. So they are mutable. We will change them when the player presses the arrow keys and initialize to the center of the screen instead of the top left corner. We will split the keyboard handling code into its own function to make our game loop more readable. It will need the root console because that's where we read the pressed keys from, and also the player's coordinates, so we can change them based on the player's actions. Okay, so in order to do that, we're going to come make a function right up. It doesn't have to be up, it could be below main, it doesn't matter in Rust. Handle keys, tcod and mute tcod, player X, and mute I32. This is not what I would normally do. We're gonna follow along with the tutorial, but I would definitely not be passing along X and Y coordinates the way it's being done here, and it may change later on throughout the tutorial. We'll see what actually happens, because there's definitely going to be a lot of things that do change throughout the tutorial. But you wouldn't want to be passing around your player's X and Y coordinates to the keyboard handler like this. Not really. So it's not perfect, and I'm not trying to throw shade at the author. I think this is a good little tutorial. And it's also based on a Python one, so I don't know. I would maybe blame the Python one more than this. But you could have still, I mean, again, we're trying to start simple and build onto it. Let me just stop. Okay, so it's going to be handle keys. It's going to take in tcod. It's going to take in player X and Y, all mutable. It's going to return a Boolean. We're going to say to do handle keys false. So we return false, and that's about it. Oh, so let me do something here. Scoot this over. It's like way too big. There we go. That's better, isn't it? A little better? Yeah, okay. All right, back to the good stuff. All right, we made our handle keys. So now, a function signature in Rust is fn function name parameter type ... because you can put multiple parameters, and then the arrow into a return type. Here we call our function handle keys. It accepts 3 parameters: the root console of type tcod console root, the x coordinate. Hold on. And that's not exactly taking in root. That's taking in tcod, which is the struct that we made. A little bit of an inconsistency there. Let's take another look at this. So yeah, you could see this tcod here is the struct that we made right here, but it has the root inside of it, and this is that tcod console. This is what they were just referencing, where they say tcod console root. But we just embedded that inside of tcod, so it seems like a bit of a typo, because we're still technically passing this, but it's inside of our own struct. We've got it buried. Anyway, so we're passing in the tcod, which contains the root console, the x coordinate and the y coordinate of types i32, and it returns a Boolean value. True says exit the game, false means keep going. The and mute bits before the types are borrowing operators. You can read about them and the ownership they're strongly tied to in the Rust book. Well, I'm going to skip past that. Again, I'm going to go through everything in the tutorial for the sake of anybody who may be watching this and not know what we're actually talking about here. But I'm also like, I'm well beyond borrowing and references and ownership and stuff. I don't need to spend time going over that. So they'll come up more throughout this tutorial. We must pass root as a borrowed value because it would be consumed by the first call to handle keys otherwise. If we just passed player X and player Y by value, handle keys could only read their values, but it could not change them. Since we want to update them based on the key the player pressed, we'll get them as mutable references. Then we can assign a new value using the dereference operator, e.g. star player X equal 10, and that will show up back in the calling scope. Right now the function's body is empty, except that it always returns false, which means keep the game going. Let's add the keyboard stuff. We use the wait for key press method to get the key and then update the player's position if it's one of the arrow keys. Let's do that. And I think they're going to break down how this works a little bit, but I'm going to do that myself as we're going here, because why not? Because I can. So let key equal tcod.root.wait for key press. Boom. True. So let's take a look at what's happening here. So we already know wait for key press has to be returning us a key. We could see it here. So yeah, wait for key press will wait for a key press event from the user, returning the key state that represents the event. If flush is true, all pending key presses are flushed from the keyboard buffer. If false, it returns the first element from it. So it seems like it just gets the first thing that happens and then throws everything else away. And then it returns back the key. So that's what we've got there with the let key equal. And then we're going to do match key. So a match statement is always fun. Now we could do something interesting here. Non-exhaustive pattern. We could go up here and say, nope, hang on. Oh, okay, we've got a, because, yeah, okay. Yeah. So we can't just have it auto fill in the match arms here because key is a struct, isn't it? Yeah, key is a struct. So we're going to destructure the struct, but it actually, some interesting stuff going on here. Yeah, because we have key codes, but then we have some special modifiers, I think, to say, were you holding control? Were you holding shift when you... Okay, I get it. Let's go in too far into depth on that. So, movement keys. We're going to have key, code, up, ... Now, this is a bit of an interesting thing you can do. So we'll take a look at that in a moment. Down, left, right. Just going to modify this to try to make it easier. Right, and this is going to be minus equal 1. This is going to be plus equal 1. Plus equal. And then it's still non-exhaustive patterns, so we have to do this doodad here. And we'll break it down real quick. Can't find struct key. You want me to import it, right? Not sure why that was not mentioned. That's fine though. So key is a struct, right? And match on the variant, qualify the path key code up. Okay, I think we need to make some slight change here. Well, now it's mad. So let's do a cargo build. Let's look at that warning down here. Match on the variant, yeah. So pattern binding right is named the same as one of the variants of the type key code. That's really all it's saying. And then if I want to, I can qualify the path. I wonder what happens if I don't. It's like a warning. It might actually still work. I'm gonna leave right alone and we'll see what happens. It builds. Like I don't see any problem. Okay. So let's just break down what happens here. We get the key and then we're matching on the key. So the key is a struct and this little doodad here is really interesting. So let's take a look at the key again. How do I get to it? Pub struct key right here. So the key has a bunch of different things and it has code, printable, pressed, left alt, left control, all that. We don't actually care about all that. All we care about is the key code that's being pressed. So what we're doing here is we are saying get us the key, get us the code, and I want to match on a key with the code up or down or left or right. And then the dot dot says, dude, just throw everything else away. That's all that dot dot means. And then here is like the code that we're actually going to run in those cases. And then finally the little, wait, is that unreachable because of this? It is. Interesting. I still want to see what happens. We're going to leave it for a minute. But yeah, the underscore here says match anything that's not covered by these other arms. So any other key, do nothing. But we'll see what happens without specifying this. It might be a change in some of the Rust edition stuff here. This was back in 2020. It was edition 28, Rust 2018, I think. And that might be a change in how you do the namespacing on these. I'm not sure though why it's complaining, because their code obviously doesn't have it. So that's interesting. So anyway, let's go back to it now and see what they say. Instead of chaining a ton of if-else expressions together, we use the match expression to specify the values we're interested in and what to do with them. The key returned by wait for key press is of type tcod input key and has several fields we can look at. Right now, all we care about is the code, which tells us that the key was pressed, but there are others for alt, control, etc. The two dots at the end mean I don't care about the other fields. If it wasn't there, it would not compile until you specified values for every field of the key struct. Rust requires that match arms are exhaustive. That means you have to specify all the possible values. However, as we don't care about the other keys the player could possibly press, we can use a special value that matches everything else. That's what the underscore arrow empty braces at the end does. You can read more about match in the Rust book. We could end here, but since we're doing keyboard stuff anyway, let's add two more. Alt plus enter to toggle full screen mode and escape to exit the game. Put these at the beginning of match key. Alrighty, so we'll do that. So before movement key, it doesn't really matter, but we'll do it. So key, code, enter, and then you want to make sure that Alt is true, meaning they're holding Alt at the same time, and then throw everything else away. And then Alt plus enter, toggle full screen. Let full screen equal tcod.root.is full screen. tcod.root.set full screen. Not full screen. Okay, so all we're doing here is we are getting whether or not is currently full screen. It's a Boolean, so if it is full screen, it gives you true. And then we're using the set full screen, and we're nodding. We're flipping that value to set it to the opposite. So that's easy enough. And then key code escape, but it's going to complain. So I'm going to go ahead and do key code escape. Return true. And that says to exit the game. And finally, we need to use the keyboard input types we have in... okay. So I'm going to do this even though we're not there right now. They did key code star and key... no, key is good. They did key code star, and they just said up. That's the trick. They just included everything in the namespace. Okay, that's better. So key code itself should be an enum. Yeah, it's an enum. I didn't realize you could actually just include the enum's namespace like that and just blow it up into your scope. Typically, that'd probably be a little frowned upon, but this is for simplicity, so it's okay. All right, so let's click back over to the browser, and then this is what I just did. And finally, we need to use the keyboard input types we have in the code. Use tcod input key and input key code. So, yep, pretty straightforward, I think. What's going on, Boxing Elephant? Now, we could put it on top of the file next to the existing imports, but Rust lets you place them in individual functions as well. Which will make them available only for that function. Since we'll contain our keyboard handling code and handle keys, let's make it the first thing there. And finally, we just update the main loop to use our key handling and draw at the player coordinates instead of 1, 1. Put this at the end of the while block. So let's go ahead and... Oh. Hold on. No, you... Yeah, I knew I forgot something. Thank you. I knew I forgot something. Okay, one second. Oops. I've done that before too. Alrighty. Oops. Let's see. All right, we good now. I think, I hope. Alrighty, where was I at? What was I doing? Yeah, so what they were saying is instead of putting that at the top, they're going to put that in the handle keys function, which is fine. It's valid too, so we'll do that. We'll copy that. Boxing Elephant here, I think, was just reminding me that I didn't change my my stream title and category and stuff, which is dumb and embarrassing. It's stupid. As I still said I was playing Cataclysm. It's like, this doesn't look like I mean, it kind of does look like Cataclysm, but not entirely. It kind of does look... I mean, Cataclysm's a roguelike. Maybe I'm building Cataclysm live right now. Maybe I'm programming it live. I appreciate the heads up, though. I was just playing it yesterday. Yeah, I've played Cataclysm in the past, and I was just playing it again yesterday. So yeah, so finally we're gonna update the main loop. Yeah, so instead of doing wait for key press there, let's see. I put this at the end of the while block. So I think instead of doing the wait for key press, we're gonna swap that out for handle keys and exit game if needed. Let exit, not exist, exit equal handle keys. And it's gonna be a mutable reference to tcod, a mutable reference to player X, and a mutable reference to player Y. If exit, I would kind of suggest instead of doing this, instead of doing any of this, you would just say if exit or if handle keys break. But we're gonna go with what they have. I'm following this, so I want to keep it closer to what they have. And then the other thing here, we need to replace player X and Y. I haven't seen them do it quite yet, but okay, yeah, they do it just below. So I'm gonna go ahead and update it. And yep, let's take another peek back over here before I run it and test it. We'll be done with part 1. So yeah, we just did this here. Let exit equal handle keys, blah, blah, blah. If exit, then break. As you can see, we're passing tcod and the coordinates as mutable references. Now update the drawing function, which is the tcod.root. And that's really it. Player X, player Y. Nothing else changes. So let's go to the next part. But before I do it, let's go ahead and run it and see that it works as expected. You should hope it does, right? Cargo run. Oh my god, it works. I'm just slamming the arrow keys and we're moving around. Just as you expect. We made a game. We made a roguelike. We have succeeded. Alt-enter. Oof. It's terrible on my end. Look what it did. Look what it did to the background of VS Code. You could even see it here. Like VS Code is just blown up in the background there. So full screen's working on my end. But I'm not going to be using that anymore because it kind of does not play nicely with anything else that's going on here. So it works. That's all that matters. I'm gonna hit escape and I'm gonna fix VS Code. So escape worked. That quit the game as expected, and we're good to go. So that's the end of part 1. It only took 53 minutes. We're gonna try to get through 4 of these today, so we'll see how it goes. Oh, it broke all of my stuff. Because full screening such a tiny window just was not a good idea. It resized everything to be really tiny that was on this monitor. Okay, so we're done with part 1. Let's go to part 2 now. The object and the map, off-screen consoles. Before we continue, let's talk about consoles. In libtcod, console is where we draw stuff. We've only used one so far, the root console. It is connected to the game window, and anything you want to show must eventually make its way there. We can, however, create so-called off-screen consoles and draw things on them. Doing so will let us add transparency effects or only render a portion of the console. It will also let us stack GUI windows on top of the main game, render the info panel and the map separately, etc. From now on, we will draw to off-screen consoles and then compose them into the root. It will occupy the whole screen for now. Yeah, so this allows us to like layer things, as it says. I was gonna say it's similar to another concept, but that's a little bit too advanced for this. I was gonna be like, it's not worth going into. Okay. So I'll put this right after we initialize our root console. So let con equal off-screen new, and then we'll want to pass con to our tcod struct alongside root, which means we'll have to add con to the tcod struct definition. So let me do those 3 things. I was like, those are really simple, quick changes. So let's make sure I just cover these all at once. So directly after initializing the root console, we're going to say let con equal off screen new screen width and screen height. Boom. And tcod will take root and con. And then tcod up here will be con off screen. So their definition of off screen here in the actual documentation is a type representing secondary consoles. It allows you to draw on secondary consoles as you would on root and then blit their contents onto other consoles, including root. There are some limitations compared to root consoles, however. Functions manipulating the main window or handling user input are limited to the root console. Off-screen consoles may not be flush to the screen directly. So that's about all it is. Glad to hear you're doing good. Always nice. So simple, quick change. Now we're going to call the set foreground clear and put care methods on con instead of root. Okay, that's a really easy change. So let's go ahead and do that. So instead of root, it's literally just con. So we're basically drawing onto that. And then finally, blit the contents of the new console to the root console to display them. The blit function takes a lot of parameters, but the meaning is straightforward. We take the console we want to blit from, con, the coordinates where to start, and the width and height of the area we want to blit. We'll blit it all. Then the destination root, where to start blitting. We'll use the top left corner, and finally a foreground and background transparency. 0.0 is fully transparent, or 1.0 is completely opaque. All right, so we're gonna do that, I guess, just before, yeah, we're gonna do that just after the con.putChar. We're gonna say blit the contents of con to the root console and present it. Blit. And in tcod.con 0, 0. I'm going to break down these parameters a little bit more because I feel like it is throwing a lot at once. And it doesn't have to be confusing. The thing is, I just read that and I have no idea what these parameters are for the most part. I could see what a couple of them are, but it'll be easier to sit there and break it down with all this on screen at once. So blit, does it actually draw? I don't know. I don't think it does. If I got rid of flush, what happens? Yeah, we get nothing. Blit just puts it on the other. Yeah, okay, cool. So everything's working. So blit the contents into the root console. Okay. So blit, it takes a region from a given console, an arbitrary location, width and height, and superimposes it on the destination console at the given location. Note that when blitting, the source console's key color will be ignored, making it possible to blit non-rectangular regions. Okay. And what do we have here? The first thing is the source console. The second thing is where to start. So we said that screen or yeah, the coordinates of the blitted region's top left corner on the source console. Oh no, that's the second one, the 0, 0 there. Then the third one is the width and height, which is just a screen, okay. Then the destination console is a root, got it. And destination X and Y, coordinated of the blitted region's top left corner on the destination console, okay. So it's just saying, again, starting at the top left. And then foreground alpha and background alpha, that transparency. Okay. So one is fully opaque. Yeah, okay. All right, now generalizing. I think we're going to make the code better. Now that we have the @ walking around, it would be a good idea to step back and think a bit about the design. Having variables for the player's coordinates is easy, but it can quickly get out of control when you're defining things such as HP, bonuses, and inventory. We're going to take the opportunity to generalize a bit. Now, there can be such a thing as overgeneralization, but we'll try not to fall in that trap. What we're going to do is define the player as a game object. It will hold all position and display information, character, and color. The neat thing is that the player will be just one instance of the object struct. It's general enough that you can reuse it to define items on the floor, monsters, doors, stairs, anything that representable by a character on the screen. Here's the class with the initialization and two common methods, move by and draw. The code for drawing and erasing is the same as the one we used for the player earlier. Yeah, so there's a lot that's kind of being thrown here, and I'll break this down. We're going to be breaking it down in the tutorial as well, but I'm going to break it down myself. That way we can have two different versions of the same thing that's going on. Note that they just called it a class. They said, here's the class with the initialization and two common methods. I don't like that. They're not classes in Rust. They're structs. I understand why they call it that, and if you're like maybe just a newish programmer, maybe all you know is some Python or something, and then you're trying to learn Rust from this, you might be like, oh, I know what a class is. That's cool, right? I got it. We got emotes coming in. This is a generic object, the player, a monster, a manster, an item, the stairs. It's always represented by a character on the screen, if I can type. It's harder to do it while talking, or on screen. All right, so struct object. That name also has some baggage with it because classes and objects are intimately related in programming, but it's not a big deal. We're gonna just roll with it. Well, hey, this this is easy. Color is of type color. Char is of type char. Okay, and then we have X and Y or I32s for our position. So let's do an impl block here. We didn't do an impl block yet. I've done them plenty of times on stream, but since this is starting from a very no experience, no programming experience kind of tutorial, or very limited experience, I should say, I'm gonna go ahead and take that extra time to explain what's going on here. That way, hopefully it makes more sense. So let me get this fully implemented first, and then we'll do that. I'm also literally practicing talking as I type and read and everything at the same time. I think I'm doing fairly well at the moment. The fact that I'm doing this and not making that many typos, not easy. You try it. So we're gonna do our move function now. So pub fn move by. It's actually harder to type what's the word? Not annotate, but maybe annotate. It's kind of harder to describe exactly what you're typing as you do it than it is to just talk about something completely different in a weird way, because your brain starts running on the two separate tracks, and it's like, sweet, I can do that. I can talk about whatever I want now. I can talk about nipples or something if I want, right? Set the color and then draw the character that represents this object at its position. All right, so pub fn draw. Now, yeah, there's something interesting here with the dyn going on. We'll have to see how that's being used here. So we're going to set default foreground to self.color, and we're going to put a character on the screen. Self.x, self.y. The glyph is self.char. The background flag is none. Okay, boom. A lot. So yeah, just kind of going at this from the simple, what is this? You never worked with this kind of stuff before. We're making our own struct here, our own data type here called object. It contains an X and a Y value, which represent its position. It contains and those are I32s, integers, signed integers, 32-bit. It contains a character or a char called char. Naming's a little, I don't normally like to call, I mean, it would be like saying, if we put another variable, I32, I don't like doing that because it's the name of a data type as well, but we'll roll with it. It's allowed. We'll deal with it. So we have a character called character, basically. We have a color called color. Simple enough. So all that stuff represents what an object can be. Again, it can be anything like a monster, an item on the floor, or whatever, because like an item on the floor is going to have a different character that represents it, like a slash for a sword or something, right? So, and then it might have its own color. It might be a gold sword, so it'll be a gold color, or a silver sword, so it'll be, everything will be identical, but then it'll be different colors. So it's, you know, nice and easy. Impl object, so that's our Rust thing where we add some functionality to a data type, and we gave it 3 functions here. It can make a new object, it can move by some amount, and it can draw itself. And it draws itself by, this is the one that I'm most interested in right now. It draws itself by getting this Dyn reference to a console. And okay, I see why. Because console is actually a trait, because there are different kinds of consoles. There's a root and an off-screen console. Okay, so let's break this down. This is going to be the most complicated one because of the Dyn keyword there. So what we do is we take in a reference to self, which just means this is like a method on the object type, and then we take in a con, which is this mutable reference to a Dyn console, and that's what I was just kind of talking about. Dyn is used when you're dealing with trait objects, and we don't have a trait that we've defined here. We just did this on the last coding stream though, so that would be a great place to see this in like heavy use. But we may see more of it in this tutorial. I don't really remember. But basically, in Rust, you can define a trait, which is essentially like a contract that says, the trait says you have to define certain functions in order to be valid, validly abiding by the contract of that trait. So then what you're able to do is have multiple data types all implement that same trait, but you know there's some shared common functionality between them because they implement that trait. So what we're doing here is we're saying anything that implements the console trait is allowed to be passed in here, because we know that there is some contract defined by the console trait that they all have agreed to, right? So really what that's used for here is it defines the common functionality between root and off-screen consoles. So we have the 2 types of consoles. They both use this same trait, meaning we could pass in either root or off-screen. So we could pass in either one. That's what the whole Dyn thing means. It's a way of dynamically doing things. And then when we actually want to call these functions on the console, it doesn't matter which one we got, because the console trait defined that you have to make a set default foreground, you have to make a put char. It told you have to make all these functions in order to abide by the contract. So that's the most complex one of these because of that dynamic keyword there. But then basically all we do is we just set the color to whatever the so I guess I should also go on the self thing here. Self is just saying whatever like the current thing is. So like we have the player object has a color associated with it that says get my color, right? Get my X and Y. Or then if a monster object later calls draw as well, the monster says get my color or get my X or Y. So that's what self means. Whichever object is calling it is going to be the one who's actually being accessed here. So yeah, we just get the self's color, we get the self's X and Y, and we use and their .char, and we use all that to draw it, to put it onto the console, right? So probably more in depth than I need to go, but I just want to explain it. I want to be clear. I want to make sure it can hopefully be understood. So move by is a lot simpler, but it does take notably a mutable reference to self. And that's because we're actually changing self's x and y value. So we have a dx and a dy value. I'm going to assume dx and dy mean delta x and y, and delta usually means change. So what we're saying is x is, so plus equals like the programming shortcut to say x equal self.x plus dx. So we're just changing x by some value dx. We're changing y by some value dy. And new here just lets us make a new one with the specified x and y value, with the specified character, with the specified color. All pretty straightforward, I hope. That one's very, very simple. Okay, so that was a big like breakdown, and I know we're about to get another breakdown in the tutorial, but I wanted to give my version of it. That way we could then also get this one here. Double explanation, hopefully something, hopefully it helps sink in better, and maybe my explanation was better, maybe their explanation's better. I'm not offended either way. So the dyn keyword in ampersand mute dyn console. All right, thanks for stopping in and giving me that heads up, and I hope you have a good day at work, Boxing Elephant. Have a good one. The dyn keyword in nmute dyn console highlights that console is a trait and not a concrete type, such as a struct or enum. Earlier versions of Rust allowed to say ampersand type regardless of whether it was a trait or not. And indeed, at least in Rust 1.37 2018, this is still allowed, but it will emit a warning. This has real-life implications, as Rust's pointers to traits are twice the size of pointers to structs. This way, anyone reading the code, us, our collaborators, people taking over, can always tell whether a pointer signature, reference box, etc. is a trait pointer or a normal pointer. I like that a lot, because it actually gives very practical understanding of why you would want to use dyn, or why it's explicit. Why it's really good to be explicit about it. And we learned about this on the last coding stream from Monday, when I was doing the ECS, Entity Component System, where it talked about how there's like a V table under the hood, this virtual table of like lookups to the functions and everything. And that's kind of what's going on here. There's like 2 pointers to like one to the object and one to the V table, if I remember correctly. I need to read more about it. But that's why the pointer to a trait is twice the size as one to just a struct. So it's kind of bringing in very practical reasons of like, even if Rust 2018 allowed it, it's good to use the dyn keyword to be explicit. And nowadays you have to be explicit. You have no choice. So anyway, now before the main loop, we will create an actual player object. We'll also add it to an array that will hold all objects in the game. While we're at it, we'll add a yellow @ that represents a non-player character to test things out. All right, so let's do that. It's exciting. We're getting NPCs already. So quick, right? So where do we want to put it? Before the game loop. We'll put it right here. So let create object representing the player. Let player equal object new screen width over 2, screen height, whoops, screen height over 2, and then we're going to put an @ and a white. And now I'm going to copy that line and say create an NPC, because I think it'll be easier to just replace a little bit here. NPU. And we're gonna slightly modify their position so they're not on top of each other. They're not banging yet. I mean, maybe our player is Geralt from The Witcher or something, but we ain't smashing yet. We gotta at least take a couple turns. Yurlo. Okay, and then the list of objects with those two. That's with those two. I don't really like that, but those two what? I'm gonna reword that with the two. With the player and NPC. Let mute objects equal player NPC. So we're not using a vector here, we're using an actual array. It's fine, it's hard coded right now, so It works very well. If you wanted to do something more dynamic, you'd use a vector because it's resizable, it's growable. But for the moment, it's fine to use the array. Or what you do, and this is actually a real thing that you might see in games, is you would actually have an array with the maximum size hard-coded in, and you say, we're never going to have more than this many things in the game. And so it's really efficient to use arrays because it's like done on the stack versus the heap. So there's like an efficiency associated with that. But we don't have to get into that. So activate browser. Oh, you're going to see it look gross for a second, though. There we go. Now we'll need to do a few changes to make it work. First, in handle keys, we'll use player's move by method to change the coordinates. This means we'll need to pass in a mutable reference to the player object. Yeah, so it's getting a little more interesting. And update the way we call the function. And then the main loop will now draw all objects. So I'm going to do, and since we're now handling color and rendering the object draw method, we can now remove the set default foreground and put char calls from the main loop and instead just clear the off-screen console. So I'm going to do all of that because that's a lot. Well, it's kind of a lot, but it's a lot of back and forth. So it'll be easy enough to just do all these in one go. Okay, so let's go to the handle keys function and take a look at it. So what do we need to do? We need to bring in a, instead of this nonsense here, which I called out, I was like, you don't want to do that. Of course not. Player and mute object. This makes a little more sense because in some way you do need to relate things back to the player. So I'm fine with that. Player.move by. And then it's 0, -1. And we can actually get rid of the star as well. Is it still up, down, left, right? Okay, good. Because I'm going to just kind of, I don't feel like mentally mapping what values to put. So I'm just going to look at it and copy what they got and hope it's in the right order. It's not hard to figure out. There is one interesting thing to note, however. Yeah, moving up is negative, moving down is positive. That's the trick in most computer graphics stuff. Positive Y is actually down and negative Y is up. I don't think they explain that here, but that is a thing, and that's shown up in some of my previous streams as well. Okay, so we have that now, and that should make everything happy there. So the function is going to be mad down here where we're calling it. So we need to pass that reference to the player. So we could do that by handle keys and exit game if needed. So the way they're doing it is they're getting the reference every time they go through. I hope they're going to change that to, hey, we know that the player is in the 0th spot, so we don't have to always get and assign this reference. I hope they're going to make it a little better, but we'll see. And then instead of put char for object and objects, yeah. So I think we're going to remove put character here. Yeah, that should be it. So for object in objects, I forgot you could do that. Wait, does it automatically? No. I could do an iter, so I could manually do an iter. Maybe that works with vectors. That's a little nicer. I thought there was a shorthand way to do that without doing .iter. I think that's what it is. I always forget. Object.draw and mute tcod.con. So we basically draw everything to the con, and then the con gets blitted to the root. I don't know if there's like a real, I mean, at this point, I don't know if there's a good reason to be doing that, but there are the advantages that you could do the cold transparency and stuff if you want. So finally, since we're now handling the color and rendering the object draw method, we can remove the set default foreground and put care. Yeah, so we'll remove that as well. Clear the screen of the previous frame. Yeah, clear the screen of the previous frame. Cool. And that's it. We have a fully generic object system. Later, we can modify this to have all the info, items, monsters, and anything else we'll require. Here's the code so far. We don't need that. So let's go ahead and go back to the code for a second. They did not run the code or any, I mean, I assume that they're assuming you're going to run it. So yeah, we got two dudes. I can move around and then it's on top of me. Now there's a good reason for that. And this is a fun thing that I would kind of ask, you know, if you're experienced in programming, you probably already know what's happening. We're in the same location. Why does that one appear on top of me? It's a very easy question, but if you're a new programmer, you might not understand what's happening. I'm going to stall for just a moment to give you time to think about it. I'm going to take a drink of my water, which used to be a cup of, oh, that's not green. It's getting green screened though. Well, yellow is close enough to green, especially with like the shadow and stuff. I get it. Yeah, like you totally see through it. That's cool. Used to be unsweet tea, now it's water. I just filled it up with water before starting. Okay, so yeah, why is it that the yellow NPC one gets drawn over me when I'm the player? Well, maybe you want the player to take precedent, but there's a good, very simple, very easy reason for doing it, for that happening. We create this array of objects that has the player first and then the NPC. When we draw all the objects, we say for object and objects. So the first thing we do is we draw the player, then we draw the NPC. Ergo, if they're in the same spot, whatever the last thing to be drawn was will be what you actually see, because there can only be one thing in one place at a time. Now, if you did like transparency things and all that with multiple consoles, you could have some overlapping, but it wouldn't really work with an @ sign in the same place because it's the same symbol. But you could have like maybe an @ sign over a slash or something. There's some cool stuff you might be able to do with that if you're like standing on top of an item with the transparency and all that. But no, very simple. I just thought it was, cool to point out, and maybe, again, if there are, people with limited or no programming experience watching this, hopefully that gets you thinking a little bit, because that should be the goal, right? Should always be thinking and learning and all that fun stuff. I wanted the browser here. There we go. Okay, the map, la mappa. Now let's build a map which will hold our dungeon. It'll be a two-dimensional array of tiles. We'll define its size on top of the source file to be slightly smaller than the window size. This will leave some space for a panel with stats that we'll add later. Size of the map. You know what? I'm not even gonna switch over. I'll switch over, but I'm gonna copy paste that one. Yeah, I don't like to copy paste a lot, but this is kind of simple enough, right? You really, again, maybe for that, I was just being lazy, but if you're actually following along or something, you should be writing the code yourself. You come across something like this, you shouldn't be lazy and just say, I'll copy paste it. No, you need to be writing this. That's how you learn. So anyway, next we'll define colors for the tiles. We'll have two colors for now, wall and ground. Let's define their dark variants. When we add field of view, we'll have to add a set for when they're lit. Okay, so let's do that. They're also constants, so they'll go right here with the maps and everything, with the map things. So const, what is it? Color dark wall, and it is a color type, and it is a color type. And it has R0G0B, 100. RGB values, RGB color values, pretty standard stuff. And what is this? Color dark ground. Right, so RGB color values literally just each one can go from 0 to 255, and your final value is a mixture of all three. So what does that represent? 16 million colors or something? I don't even know. Whatever 24 bits is. I have to check now. 2 to the power of 24. Yeah, 16,777,216. So it gets you like 16 million colors. 000 is black because there's no value to any of them. 255, 255, 255 is white because they're all maxed out, basically. And then everything else is some like gradient in between. Okay, so easy enough. Theirs looks a little different. Oh, if I format, I get the same thing they have. Okay. Let me move my browser back. Since the map is going to be built from tiles, we need to define them. We'll start with two values, whether a tile is passable and whether it blocks sight. It's good to keep the values separate from the beginning, as it will let us have see-through but impassable tile, such as chasms or passable tiles that block sight for secret passages. We'll create a tile struct. Alrighty, so let's go ahead and start working on that. This will be fun. We'll put it down below the object. It doesn't matter where you put it. I'm just putting it where I feel like putting it. A tile of the map and its properties. Alrighty, and they do a derive, which we haven't seen today, but I do all the time. This syntax always used to throw me off, like where to put the like pound and like, do I put the derive before or after the bracket? Always gave me trouble. I seem to have learned it at some point though. Struct tile. I do them all the time on my streams. You've seen me do them plenty of times before if you watch these. But I will explain it again because I feel like this tutorial is definitely more beginner focused. So why not? That's not to say there's anything bad about the tutorial, by the way. I'm not trying to say that. Like, I'm doing it because I think I stand to benefit from this, even though I'm calling it more beginner focused. There are things here that will help me, even though I'm pretty comfortable with where I'm at as a programmer. So I'm not trying to say anything bad about it. I wouldn't be doing it if I thought it was a waste of my time. Okay, so we have empty and wall being defined here, and both can just make tiles with different they can make tiles with different properties. Okay, so there we are. Where are you, Mad? Oh, I missed a comma there. That freaked everything out. Okay, there we are. So we've made a struct tile. It has two Boolean values, true, false values. It's either it's blocked or it blocks your sight. So blocked meaning you can't walk over it. It's impassable. And block sight meaning it blocks your sight. Easy enough. So an empty tile is neither. A wall is one that you cannot pass and it blocks your sight. So then we could also come up with other variants of it. But those are the two different types of tiles we can kind of make right now. Okay, yeah, I'll buy it. There's other things we could do with tiles if we wanted, though. We could do like an enum or something. We could do an enum of like, well, I won't get into it. I should though. So you could do this. Enum, tile enum, and you would say empty wall, see-through wall, like whatever, right? you could put as many variants as you want here, and you could use that as another way to handle this. And then you're not juggling different variables, but there may be some benefits to this, so we'll see where it goes, right? So, and I was going to mention derive. Basically, these are traits. Debug is a trait that basically says it's a let me think of how I want to say it. So debug is like the debug representation of something. If I want to print it to the console down here with goodbye world and all that, there are two ways to do it. There's a display trait and a debug trait. So you cannot derive display, but you can derive debug, and it basically just slaps in, it'll basically be this right here exactly. Tile blocked, and then it'll be true or false, whatever the value is. Block site, true or false, whatever the value is. So it makes just a very like raw representation of the data, but it derives it for you. You don't have to come up with it yourself, so then you can easily print it. Clone and copy are two different ways to move your data around. I really need to read more on the exact differences between the traits, but copy, I think it might be the difference between deep copy and shallow copy, but I should double check that. Let's do it real quick. Rust clone, Rust copy, because I obviously don't know enough about them, so let's double check. Oh, by copying bits versus okay, yeah. That's what it is. Copy is implicit and is an inexpensive bitwise copy. Right, that's right. Clone is always a little bit more expensive. Clone is explicit and may or may not be expensive. Okay, so copy literally just takes the bits and copies them over to another. Okay, got it. And then there's a whole thing about like move semantics and copy semantics. That's actually a thing that comes into play when you're like passing around functions, or here where they're doing this. Yeah. So this gets into the whole borrowship. I keep saying that ownership and borrowing system, where if you set y equal to x here, without doing copy or clone, then we actually lose access to X because it's been moved into Y. But by doing copy and clone, it actually does that implicit copy. So those are the copy semantics that are being mentioned here. So there are some advantages to that. And what it literally did was copy the bits. Okay. Good. So yeah, those are two traits that simply define how you duplicate data in different ways, right? Okay, so the derive bit automatically implements certain behaviors. Rust calls them traits. Other languages use interfaces you list there. Debug is to let us print the tile's contents, and clone and copy will let us copy the values on assignment or function call instead of moving them. So they'll behave like integers in this respect. Yeah, so we don't want the copy behavior for object. We could accidentally modify a copy instead of the original and get our changes lost, for example. But debug is useful, so let's add the debug derived to our object as well. Okay. Why not? Oh, whoops, I'm on the impl. I just looked for object and went to town. Okay, cool. Alrighty, what's next? We've also added helper methods to build the two types of tiles we're going to be using the most. And now the map. It's a two-dimensional array, a vector of tiles. The full type is vec tile, a vec composed of vecs of tiles. Since we're going to be passing it around a lot, let's define a shortcut. So this is something you don't see me do often, but this is simply a type. It's a type alias. to make it easier to say map instead of vec tile. So easy enough, and then we're making this game struct. Let's go ahead and do that. Do it right under tile here. All right, so type map equal vec tile struct game map. Easy enough, right? This lets us write map wherever we'd have to write vec tile, and it's also easier to understand. We've also created a new game struct. The motivation here is identical to the tcod struct. There are going to be things we will almost always want to pass together, and this will save us some refactoring later. It'll also come in super handy when we get to saving and loading. Now we'll build it using nested Vec macros. So we're going to make a function make map. Now map is not like some special data type that we made. We're not going to be doing like an impl block or anything. Kind of could, but we're not going to bother with that. I think you could do impl for map or impl map, and then make a new function. That would be interesting. So we're gonna do this make map, and seems straightforward enough. Scoot this over. Okay. I'm still curious about the impl map. You cannot do it. Okay. All right. I thought you might be able to get away with it. You could do traits. If you define a trait here, you could do it. Anyway, sorry. Fill map with unblocked tiles. Let mute map equal, okay, so we're making a mutable map. Oh, I see what we're doing. Yeah, okay. So we're gonna do this vec. I was like, does it need to be? I don't actually think it needs to be made mutable right here, does it? Whatever. Okay, so tile empty. This is almost like a list comprehension. Not really. It's just two arrays, I guess. So this is something I don't think I knew that the off the top of my head, I don't think I knew. This is why I said the list comprehension thing, because I was like, wait a minute, you could do this? I didn't realize the Vec Macro could do this and specify a length. Create a Vec from a given element and size. I don't think I realized it could do that. That's good to know. At least if I did know, I've forgotten. So yeah, we're just gonna say, give me a bunch of empty tiles. We're making them by column, right? Yeah, it seems like we're making them by column. Give me however many are in map height, and then do it once for each column, or yeah, for each of the width, basically. Strange wording. I'm trying. Okay. So the Vec macro is a shortcut that creates a Vec and fills it with values. For example, Vec A42 would create a Vec containing the letter A 42 times. We do the same trick above to build a column of tiles and then build the map of those columns. We can access any tile with map XY. Let's add two pillars, block tiles, to demonstrate that and provide a simple test. Okay, so we're just gonna slap that somewhere in the code. Well, where are we doing that? You can also access the tiles property directly like so. Next, we need to draw the map on our window. Oh, I think that's why we made the map mutable, so we could change it. Okay, I see. I see. So let's go ahead and do that. Tuss finally got some sleep. So we're gonna place it in here. I was thinking it doesn't have to be mutable here. Place 2 pillars to test the map. Not 509. So I do have some concerns with hard coding the values in, because what if you change the size of the game? Or what if you change the size of the map or something? Hard coding these values could get you something that's actually out of bounds of the map. You don't want to do that, but it's fine, I guess. So let's click back over. You can also access the tiles property directly like so. So we could, yeah, we're like map 3022, we could say dot blocked equal true. Next, we need to draw the map on our window. Since we need to draw both the objects and the map, let's create a new function that renders everything and call it from the main loop. We're gonna call it render all. Okay, and then still in the same function, we can go through all the tiles and draw them to the screen. And let's move blit to the end of render all. So let's go ahead and do all that, and then we'll be back to the tutorial thing here, because there's a lot happening. Let's do function render all. Alrighty. I forgot you could you didn't have to specify the size of an array. I forgot you could get away with that in Rust. I usually use vectors. I've done arrays sometimes when it makes sense, but I often find it easier to use a vector for whatever I'm working on. Usually though, if I know the size at compile time, I go ahead and use arrays if they're not too large. Okay, so that's easy enough. Still in the same function, we can go through all the tiles and draw them on the screen. So let's see, go through all tiles and set their background color. So for Y and 0 to map height. Again, I'm going to talk about this as if you don't know how to code, because this is more of a beginner-centric tutorial. libtcod is supposed to be simple. So kind of the point of libtcod is that it takes a lot of the complexity of like map gen and like field of vision, like field of view, all that fun stuff. I use fun loose, you know, maybe you don't think it's fun, but all that stuff that is a little bit more difficult to figure out, a lot of that's taken care of by libtcod. So it's pretty nice. Also, why is, hold on, let me make sure I didn't make a typo somewhere. Oh, did I just do cod? Yeah, okay. I think I did .con, sorry. Yeah, there we go, okay, cool. So it takes away a lot of the more complex stuff that you might be dealing with, and just allows you to kind of call a function that does it for you. So, I mean, that's great and all, but if you really want to, like, you know, get more in depth, there's, you know, other stuff out there, right? But this is definitely more centric around like you're kind of a beginner and you don't want to deal with that crazy stuff. You just want to get like a working game going. This is your you know, a much quicker path to it, right? So set care background, XY, color dark ground. And so what I'm going to be doing after I finish this is a much more complex tutorial that gets into all the nitty gritty of things that we're going to be skipping here, thanks to libtcod. But again, that's not a reason to discount it. But so what I'm going to do though, is the point of that, so I could ramble while I was typing, was basically to say that, actually, can I just copy this? It was basically to say, because of that, I'm going to keep the trend up of like explaining as if you're a new programmer and maybe, you know, need that extra explanation. So let's take a moment to break down what's happening here. Well, we have the same draw thing as before, so there's not much to break down there. Let me, hold on, let me put that render call in here so I don't lose where I want it. So we're going to remove the objects there, and we're going to say render all, and it's going to be that, and that, and that. It needs to be, did I not make game yet? I haven't made game yet. Okay, we'll make it in a moment. We'll get that. We'll make sure that's happy in a moment. It should be a reference to game, right? Yeah, it's a reference, not a mutable reference. So just a reference. So boom. Okay, let's break down the function for a moment so we can understand how everything in the game is rendered now. We have our array of objects coming in. Every object in the game comes in this array, and we just say object.draw. We have a loop through for object in objects, object.draw. And that's really all there is to it. We draw it to the con, which is the off-screen console, right? And then we go through all the tiles in the game and we set their background color. So basically we have this whole map height and map width. Think of it like a grid. And we do for loops through those values. So we say from 0 to the map height, so 0 to 45, and from 0 to the map width, 0 to 80. It's this nested for loop. So we start from the y value, and then we go through all the x values, do the next y value up, do all the x values, do the next y value up, do all the x values. So we're basically going line by line, building out the grid. And then what we do for each one of those, we get that wall from the, what we're actually doing, we're not getting the wall, I should say. We're getting whether or not it blocks your sight from that specific tile from the game map. And then if it does block your sight, that's what we mean by if wall. If it does block your sight, then we'll color it dark wall. Otherwise, we'll color it dark ground. So straightforward. It's either a wall or a ground at this point. We can't really do anything else with it, but it's something, right? So then after that, we just do blit to take con and put it onto the actual root console, which we've been doing before, so I'm not going to re-explain how that works. And then, yeah, the other note, well, they're mentioning it, so I'll just read it from the tutorial. So we've replaced the screen dimensions with the map ones. From now on, the con off-screen console object represents the map only. So now we've abstracted that to be the map. That way we can do something else for like the user interface or whatever. Okay, see, now it makes sense. This gives some space at the bottom for the message log, status bar, etc. And we need to update its dimensions in the main FN as well. So let con off screen equal new map width and map height. So let's go do that. Where is con? Map width, map height. Now that we've got the map and rendering updated, let's actually create it. In main, before the game loop, let game equal, okay, yeah. And don't forget to call render all from the main loop too, right before tcod.flush. You should be able to see, okay, yeah, we'll take a look at it. Let me go ahead and add those changes. So just before the loop, we'll go ahead and make game. Let game equal game. Generate map. At this point, it's not drawn to the screen, of course, because we haven't told it to draw yet. Map, make map. Okay. And then render the screen. We've done that. Render all just before flush. And mute tcod and game and objects. Boom. You should be able to see two pillars and walk around the map now. Well, let's find out. Can we do it? Oh my goodness. It's a game. We have made a game, boys. Not a Game Boy, like not a... Don't sue me, Nintendo. Okay, there we are. We can walk around. Now, we can't really do anything interesting here because, well, there's no logic. There's no interaction or anything other than walking around. But we got the two pillars that we created, that we hard-coded in, and we can move around. It's working. And you see that black at the bottom there now. That black bar, like, right here. I'm trying to grab it. That black bar right here. That's where, like, our status and our text and stuff are going to go. So that's going to be cool once we get to that point. So yeah, let's head back over here. You should be able to see two pillars and walk around the map now. But wait, there's something wrong. The pillars show up, but the player can walk over them. That's easy to fix, though. Add this check to the beginning of the object's move by method. Right, let's go do it then. What do they want me to do? Move by. All right. Except we're passing in game as well, so we're gonna have to pass in game to get access to the map, so we can check against the map. Basically, some very basic collision detection. So if not game.map self.x plus dx as usize. Self.y plus dy as usize dot blocked. And that's all there is to it. So what's actually happening here? What does this check do? Well, we pass in game, so we have access to the map. So we get the map, and then we want to check the spot that we're moving to. So basically, our current position plus dx, which is the same place we would move down here, and the same thing for y. So we see that here, self.y plus dy. We want to basically use that next position where we're trying to move, and we want to ask, hey, is that space blocked or not? If it's not blocked, then go ahead and move. Otherwise, do nothing. So nothing else actually has to change. And then we're going to run into an issue. We could already see some red there. So let me switch back over because they're going to explain some of this too. So they say, yeah, we need to pass map in to check if a tile is blocked. Only move if the destination is not blocking. The movement code is the same. We also need to pass a reference to the map to handle keys because it calls move by. This may look annoying now, but as the code grows, it'll be good to know which functions can see and change what. So basically, we're just going to add that game into handle keys, and then move by is going to need access to game as well. So we see that here, added game to handle keys and passing game to move by. And then finally, we need to pass the map to handle keys from the main loop. So let's take a look at that. And really, in this case, we can have a bit of a conversation with the compiler, or I'm not actually compiling it because I have the nice linting. I have the nice linting here in my VS Code window that tells me all the errors that I would get if I did a cargo build or cargo run. So this is kind of like having a conversation with the compiler, and it says, hey, we need 3 arguments, but only 2 were supplied. It's missing game. So we'll say game, and game, and game, and game. But now it's complaining because it can't find game in this scope, right? So that's where we say, okay, I'll add game here. And game. And now that's happy, but the next place we see an error, again, is like a conversation with the compiler. Why are you mad? Oh, because you need end game here, right? Of course. So now everything is happy. Now I can build. Now I can probably also run. And unless we miss something, I can't walk through. I'm pressing up. I'm pressing right, pressing down, pressing left. So we're good. So we can't walk through the wall anymore. So now let's go back to browser. Finally, we need to pass. Yep, we've done it. Here's a complete code so far. Okay, so there's two things here. There's a ton of different ways to create the map. One common alternative is one continuous vec with map height plus map with, or times map with items. To access a tile on XY, you would do map y times map width plus x. The advantage is that you only do one array lookup instead of two, and iterating over every object in the map is faster because they're all in the same region of memory. So that is is that row major or column major? I think that's called row major order. That is actually something I like to do. It's a little bit more confusing, but you think about it like if there's if it's 10 things wide, you basically say what column are you in? Are you in the 0th column? Then it's 0 times 10 plus whichever thing you're actually, or not column, what row are you in? Excuse me, what row are you in? If you're in the 0th row, you say 0 times however wide each column is, 0, plus then whatever column you're actually in. If you're in the 2nd column, it's 2 times however wide the column is, plus whatever exact column you're in at that moment. Sounds a little odd. It takes a minute to break down. You got to like draw pictures and stuff to learn how it works. But it's way more efficient. You see it a lot in C code. I like to do that more than 2D arrays usually. You can even extrapolate that to a 3D or a 4D array. The math just gets a lot more complex to look at. So in those cases, it's actually really helpful to in those kind of cases, it's really helpful to build out some little helper code or something, a little helper macro or something to convert a simpler syntax into something a lot more complex. But anyway, what's the other note down here? Or you could treat walls and everything else in the map as just another object and store them there. This would make the game structure simpler. Everything is an object and more flexible. Just add HP to make a wall destructible or damage to one that's supposed to be covered with spikes. There you go. You could also do that stuff with enums as well, but it might get very complex. You might have a lot of different enums. We might get into the entity component system here too, of adding components to the walls and stuff. So there's a lot of ways you can do things, right? Games are not necessarily extremely rigid. There's only one way to ever do something. All right, so we are in part 3 and it only took 2 hours. So we're going to try to get through 4 parts if possible. We'll see how it goes, right? What does the field of view one look like? And it's about the same length. It's actually longer than the one we're... Oh, wait, I'm in the wrong one. Hang on. It's a bit shorter than this dungeon one we're doing. The dungeon one looks like it's going to be a little lengthy. So we'll see. All right, so part 3, dungeon building blocks. Having a painstakingly handmade room with artfully placed pillars is all well and good, but roguelikes are about procedural generation. How about adding some randomness to the mix? We're going to carve rooms and tunnels in underground rock. In this section, we'll build some helper functions, which we'll use to then generate the whole dungeon. First, a struct that will represent a rectangular room. Alrighty, let's build it. Let's do it. Let me just go down and add it to the bottom right under the last structs that I did. Right under game. Why not? A rectangle on the map used to characterize... they spell it with an SE because they're not American. So we derive clone, copy, and debug. And then it's a struct called rect x1 i32 x y1 i32 x2 i32 y2 i32. So these define the extents of the rectangle. Basically, you don't need to define 4 corners to make a rectangle, you need to define the opposite corners because everything can be derived from that. So this is defining the extents of a rectangle. I think that's how you would word it. Impl rect, and then we're going to make a function here called, not a function called new, and it's going to take in all those things that we just talked about. Actually, it's going to do a little bit differently. It's going to take in width and height, and it's going to calculate the values from that. So we're going to say rect x1 is x, y1 is y, and then x2 is x plus w. Whoops. W. And then y2 is y plus h. And there we have it. So pretty straightforward because we're saying we start with an x and a y spot, and then we've defined the width and the height. So we go over a certain amount and down a certain amount, and we have a rectangle. That's how we define our points, basically. Okay. The rectangle stores the coordinates. Okay, wait, I gotta go back over. Someone's either on my I mean, I don't think anyone's literally on my balcony, but like someone just sneezed hardcore outside. It was way too loud. Anyway, the rectangle stores the coordinates for the top left and bottom right points. This function will take a rect and place it in the map, making sure all the tiles are empty. So create room. Let's do it. Let's make a room. I'm gonna go back down. I'm gonna do it near make map, okay? So we're gonna do create room. So we basically need a rectangle, and we need the map itself. We need a mutable reference to the map itself, right? Because we are changing it. So we're going to go through the tiles in the rectangle and make them passable. For x in room dot x1. Oh, that's what's throwing me off. Room dot x1 plus 1 to room dot x2 for y in room dot y1 plus 1 to room dot y2. Map x as u size, y as u size, equal tile empty. All right, and I know they're about to describe this, but I want to see if I understand, because I didn't read ahead yet. They say, like, what's with this +1 business? I'm not sure. I do know why they're doing. Oh, they're doing the border of the rectangle. I think the +1 gets us the border, because when you do a range-based for loop like we see here, it does not include the last value. So that means you won't actually hit the last value, but then by doing this, you also won't hit the first value. So you're actually shrinking the rectangle in by 1, basically leaving a wall, leaving a border, leaving an outline. I think that's what they're doing here. So we'll see how they describe it now. So the +1 business here is a bit subtle. The a.b notation specifies a range that's inclusive at the beginning but exclusive at the end. For example, 1.5 represents 1, 2, 3, and 4, but not 5. So to go through all the values between x1 and x2, including both, we'd have to write x1.x2 plus 1. But we want to make sure each room is enclosed in a wall, so we want to go from x1 to x2 exclusive. To do that, we add 1 to the first coordinate and subtract 1 from the second, ending up with x1 plus 1 dot x2. If x1 is 1 and x2 is 5, we would put empty tiles at positions 2, 3, and 4 and leave 1 and 5 solid. To test, place 2 rooms and make map. Okay, let's try it. Where is make map? Right here. So we're getting rid of that. We're going to say create 2 rooms. Had to make sure we're on the code, not the browser. Let room 1 equal rect new 2015 1015. Let room 2 equal rect new 50 15 10 15. Create room 1 and mute map. It's gonna get mad. Oh no, it's not, because we're in the same function. My bad. I was like, we're gonna have to pass map in. I forgot we made it here. My bad. Before testing it out, make the player appear in the center of the first room. Okay. So I know I didn't switch back to the browser, but it's a really simple, quick thing. So where is the player defined at? Let's see. All right, we're gonna change these to. We're hard coding the value, so that's fine. Create new object. Place the player inside the first room. Okay. Yeah, no, that's fine. Let's go ahead and test it and see what happens. Apparently nothing. Cargo build. What am I doing? Well, time to double check. I must have missed something. Let me take a look around here. Create room. Like, I'm happy with everything I see. Oh, I see. We're now filling, yeah. I didn't swap this, so we want to make everything is a wall except for what we carve out. Yeah. So it's really subtle, but it says fill map with block tiles, and then you change that to wall. There it is. Got it. And there we are. Now I can't walk out. I'm trapped in here forever. The poor yellow dude, he got like buried alive. He's just stuck in there in the wall. Like, he's dead. But I'm stuck in here. I can't leave. Right? So that's our game, but it's cool. It's something, right? We're changing. We're adding more slowly, and you can see how you could start making something out of it now, right? So let's keep pushing on, because it's going to get way cooler. It's going to get way better. Before testing out, make sure the player appears in the room. Yep. So we've done that. You can walk around the first room but not reach the second. Let's add a function to carve a horizontal tunnel. Okay, so see, it's getting more interesting already, yeah? FN create H tunnel. Okay. Horizontal tunnel. So I think the idea, I mean, I haven't read far enough yet, but oh no, I see how they're gonna do it. Never mind. Min and max are used in case x1 is greater than x2. Okay, so what are we gonna do? For x in compare, I think we need to include compare to use it. Isn't it std cmp? Okay, it's fine, never mind. X1, X2. Yeah, so we get the smaller and then the larger. Okay, yeah, I got it. Okay. Failed to resolve use because I need to include it. Oh, yeah. They did do it. Okay. Thought it was weird that it was maybe going to let me do that. All right, so create H tunnels. So basically, we get the smaller of x1 and x2, and we loop from that to the larger of x1 and x2 plus 1. And that's because we want to include the end. I got it. Okay. And then we just set all the tiles between that as empty. It's going to be a one, like a one block tall tunnel. It's going to be a really narrow tunnel, but it's going to be a tunnel. And then we're going to do the same thing for a V tunnel, but we're going to swap it. So this is where I say it's okay to do a little bit of copy paste, but you got to be careful. You got to be really careful. Actually, there may be a catch here. I'm just blindly changing these values. Wait, where's the Y used in the first one? Hang on. Oh, I see how it's used, yeah. So then it should be Y1, Y2, and X. Now I think there's going to be a catch here. If you've been paying attention, you might know what it is. When we're dealing with Y values, no, it's not going to be a big deal. Not in this case. Because whether we're going up or down doesn't really matter, because we're going to be covering the entire gap. So it shouldn't really, yeah, it's not going to matter. In other cases, it might if direction were important. So yeah, we're good. Alrighty. Take another look back over here now. So yeah, we did the vertical tunnels. So we're using tile empty to carve out the empty tiles in the map. That means we're replacing the existing tile with a new empty one instead of just modifying its blocked and block site fields. This is easier to read and write, but it wouldn't work if the tiles already had some fields you care about set. Say if you ran the dungeon generation in layers and an earlier function already set some properties you'd like to keep. Now we can connect both rooms with a horizontal tunnel and make map. Create H tunnel. Okay. Let's take a look at it. Let's go to make map. Where is make map? Create room, and then create H tunnel 25, 55, 23, and mute map. La mapa. All right, and I guess let's run it and let's see what it looks like, right? Let me get all my stuff scooted around here real quick. Boom, and a boom, and a boom. We got a tunnel. We can walk between the rooms. It's good stuff. I don't think I have much else to say about that, but it's getting more like a level, more like an environment you would actually do stuff in, slowly but surely, right? So now we have all the pieces we need to make something more interesting, and I think that's what we're about to do. Now my neck is killing me. All right, dungeon generator, and now we get to build one of the most integral parts to every roguelike, the dungeon generator. It's a huge part of the character of your game, and it's what gives it the fabled infinite replayability. There's a ton of ways to build your worlds, and each may suit a different game. We'll use a pretty simple algorithm. First, pick a random location for the first room and carve it, then pick another location for the second room, such that it does not overlap with the first. Connect the two with the tunnel and repeat. This will yield a sequence of connected rooms. So we need a method to check for room intersections, and we'll add one for getting the center of a room as well. That's where tunnels will start from. Place these in the impl rect block. Okay, let's do it. See, isn't this cool? Like, here in the next few minutes, relatively speaking, here in the next few minutes, we're going to have, oops. Oh, sorry, I was in the browser and I just did a search for what I wanted to do in the code. Where were we at? Right there. Everything over there looks good. Okay, impl rect. Yeah, so here, relatively in the next few minutes, we're going to have an actual map generator that we can walk around and explore. And it's going to be very bare bones, but I've only been working on this for a little over 2 hours now, right? So just let that sink in, how quickly you can make something interesting if you know what you're doing, if you follow a tutorial. But I mean, I could probably build something like this quicker on my own if I'm not, you know, talking about it, basically. Not trying to explain various things. Eh, it's not a big deal though. It's fun. I enjoy doing this. To me, the idea of like explaining it as I go along, I think that's almost better because it makes me understand it more. So one of the concepts is if you think you understand something but you can't explain it, you don't really understand it that well, right? I mean, there are some catches, because I remember hearing a quote, I think it was Richard Feynman, who's like, if you think you understand quantum electrodynamics, then you don't. And he was like the foremost expert in quantum electrodynamics. So, you know, leave it to him to say something like that, I guess. And I'm not going to necessarily question him. He's a great writer, though. I have some of his books, some of his lectures. There's basically just lectures, at least what I have. But yeah, the idea is like it's a very complex field, and if you think you just understand it and you're somehow smarter than everyone else, it's like you probably don't. You're probably not. Okay. So there's a lot of stuff that I just typed out while I was talking there, while I was blabbing. It's a lot of fun. I feel like I'm getting all right at talking and typing. I just have to dissociate and talk about something different. We're going to add a couple constants as well, then I'm going to get back to explaining that code a little bit. So let's just go right here and do parameters for dungeon generator. That's not right either. Const room max size I32 equal 10, not 190, 10. Const room min size I32 equals 6. Const max rooms I32 equal 30. We'd have 30 rooms up in this piece. Alrighty. Now let's go back to not create room. Okay, yeah, so center. Let's look at the center of a rectangle here. To get the center of a rectangle, we need to get the center X and the center Y value. So we get the center X value by taking x1 plus x2 divided by 2. It's literally taking the average. We do the same thing for the Y value. Literally take the average of the two, and then we return those as a tuple of they're both I32 values. So here we see a tuple I32 comma I32. We simply return them both. That's our center point of the rectangle. And then to ask if something intersects, that's a little bit more complex. So what we basically need to do is check against two different rectangles and see if any of their points cross over. So if self.x1, which is the upper left, is smaller than or equal to the bottom right of another rectangle, and the top left, or no, and the bottom right of the first rectangle is larger than or equal to the top left. So this is this weird thing, and you almost have to draw a picture out and like label each of these. I'm not going to try and verbalize this because it's very difficult to verbalize, right? But what you're doing is you're having to check all of these different points and say, well, is this one larger than that one? Is that one larger than that one? And it's like, okay, they intersect, right? So it's a little funky, a little wonky, but that's the most basic collision detection you can do. And in fact, that is used all over the place in very basic game collision detection. And let me make sure I got all the stuff right. X1, X2, X2, X1, Y1, Y2, Y2, Y1, and that way, that way, that way, and that way. Good, I got it all right. Cool. This is used because in games, usually rectangles are going to be the preferred way to do collision detection. Doing like mesh colliders where you actually try to make the collider match up with your object, they're actually a lot more expensive because they're basically these really complex shapes. Squares, rectangles, boxes are really simple shapes, and it's easy to just check a few values against each other. But the more complex the mesh collider is, if you want to have like realistic collisions, the more computationally expensive it is, and it's going to slow your game down. So like if you actually look at a fighting game and you see the hit boxes, they're usually just squares. They're literally like rectangles and squares, and they're close enough. They're close enough that it looks and feels all right when you're playing the game. So that's really all that, all that matters is that it looks and feels all right. No one's going to care that it's not 100% accurate, right? So that's one of the most basic collision detection algorithms you'll ever see, and it's used all over the place. Okay, so we've added some constants and stuff. We've done some other stuff. All right, that's been a few hours, Tusk. Yeah, it's not bad. Okay, so yeah, we had the constants, room max size, min size, max rooms. We just did all that fun stuff I just explained. And now for generating random numbers, we're going to use the rand crate instead of libtcod's random number generator because the former has been designed for Rust and has more functionality. To enable it, open cargo.toml, add this in your dependencies, and put this on the top of your source file. Okay, I'm going to do those. I'm not going to click over to show it because I don't think it's necessary. That rand is super out of date, 0.3.9. The newest version is 0.8.5. I'm going to keep the old outdated version because this tutorial was written with that version in mind. So it will be easier to follow along. I actually know from personal use that the rand crate has changed its API over the years. So there is a great likelihood that many things would no longer be correct if I were using a newer version of the rand crate. I would have to make adaptation, and it doesn't mean I can't do it, but I'd rather just follow along. Simplicity, right? So with that out of the way, let's actually implement the algorithm in Make Map. Remove the previous code that created the example rooms and tunnel, and instead make a loop that goes through the maximum number of rooms, assigning random coordinates and size to each one as we go. So there's going to be a lot happening here, and then we'll store the created rooms and the room. Okay, so there's a lot going on here. So let's just start breaking it down, putting the code in. Tusk over here watching. Tusk learning how to code right now. Tusk is learning how to make games. Let me just verify something. Yeah, we'll get rid of the example rooms and the tunnel, right? Okay, so let mute rooms equal vec. Now here's the fun thing. I like to show this. It's a vector of unknowns because we don't know what it is, right? So we're going to figure it out really quickly. Basically what ends up happening is this is Rust's type inference kicking in because I haven't put anything in Vec yet. So if I said rooms dot push 12, now it's going to change it to an I32. But we're not going to do that. We're going to say for whatever in 0.max rooms. Now I say for whatever because the underscore means throw it away. We don't actually care about the value. We just want to loop. We just want to loop through these this many iterations. We don't actually care about the number. We're not going to use it. So random width and height. Let w equal rand thread rng dot gen range room min size room max size. Now you're like, what is all this? This is the rand crate. You just have to learn how the crate works. But we can see here that gen range takes a low and a high. We're just generating a value between low and high. That it's not difficult really. So we're gonna get a height as well. Nothing else is different about it. We're just gonna get a W and H from min and max size, just like that. Simple, easy. And then random position without going out of the boundaries of the map, of la mappa. Let x equal rand thread rng dot gen range 0 map width minus w. We're gonna do the same thing for y, except it's gonna be map map height. And minus h. Alrighty. So let's move on forward. I got you on that hydrate. This is water. It used to be unsweet tea and I filled it up with water. Alrighty. So next we'll store all the created rooms in the rooms vec and use it to check for intersections with any new room we create. So yeah, this is why we made that intersection code just a few moments ago. So let's see, Wesley. I think we're gonna do that in the for loop. Let new room equal rect. New x, y, w, h. Run through the other rooms and see if they intersect with this one. Let failed equal rooms dot iter dot any. You know what makes me sad is I did this tutorial 2.5 years ago and I didn't really know about any. That part didn't stick with me, but any's really cool. I just did it on stream a few weeks ago with my alarm that one day I'll finish, I swear, I promise. But any says that any of these, if just one of these has to return true. So you can go through an entire iterator of 6 million items. The first thing that returns true, you're good. You stop processing. So we're just saying, does it intersect with anything? That's all we're asking here. But we have to use a closure. And again, I'm treating this kind of as this tutorial's designed for more beginner-friendly, like a more beginner-friendly approach. So closures are weird. I know this is going to explain closures at some point. So I will let it get to that point before I get too much into it. I see it mentioning it right here. So we'll see what it says. But basically, we're just saying, do any of these rooms intersect? If so, we mark it as like as failing, basically. That's the idea here. I'm not going to have much in the way of story here, but you could always add story. I mean, it's hard to do story in a roguelike task, but it's doable. I made an adventure game in school. Like, just a quick aside, I don't want to get too distracted from the what's at hand here, but quick aside, in one of my courses in school called Symbolic Processing, which was a prerequisite to the AI courses, we were using a programming language called Lisp, and we made an old school like text-based adventure game where we defined like a bunch of different rooms and buildings and houses and stuff, and you could go into the places and interact and pick up items and talk to people and stuff. It was a lot of fun. Anyway, so here's what we just did. And so we did this rooms.iter, and it says, the iter method returns an iterator, a value we can query for each item in the vector. Iterators are really handy in Rust because they have a bunch of useful methods one might want to do on a collection already defined. The any method runs the code in the parentheses, which is a closure for every item in the rooms vec. As soon as it encounters false, it will abort. Now we know whether the room is valid. If it is, Actually, I think they said that backwards. Any is true. As soon as an encounter is true, it will abort. And I'm going to go confirm that. Bear with me. Let's go back to the... Go away, stupid notification. You're blocking what I need to click. Oh my god. It should... I thought running OBS would block Windows from making notifications. I thought we just looked at this too. Any takes a closure and returns true or false. It applies this closure to each element. If any of them return true, then so does any. If they all return false, it returns false. Yeah, they have it backwards. They have it wrong. I'm gonna issue that live correction to the tutorial here. As soon as it encounters true, it will abort. But they all have to return false for it to be false. They are using it correctly, but they've described it incorrectly. They haven't described closures yet. I will hold off because I do remember them describing them later. I'm pretty sure. So anyway, now we know whether the room is valid. If it is, we can carve it with create room. We'll also handle a special case. The player will start at the center of the first room. We'll pass the player into make map and set its position there. Alrighty, let's do that. Make map, we now need player and mute object. Okay, should complain that it's unused. Oh, right, because we're not passing it in yet. We should just be able to do and objects 0. And mute objects 0. I'm getting a little bit ahead, but I could just make it happy. So now we go back to make map, and it's unused player because we're actually not using it yet. But I like that helpfulness. It's there. So what are the changes we're going to do here? If not failed, this means there are no intersections. So this room is valid. Paint it to the maps tiles. So we do create room, new room, and the mutable map is good. Then center coordinates of the new room will be useful later. Let new x, new y equal new room dot center, just like that. If rooms dot is empty, this is the first room where, not ROM, room where player starts at. Player dot x equal new x. Player dot y equal new y. Okay, there we go. And in main, I'm not going to click back over for it, but in main, get the starting position from make map and use it to set the player's initial coordinates. What? No. I don't really understand what they're saying there, but that's the whole point of setting it there, is that we're whatever. We're fine. Yeah, we're fine. Okay, so let's go back to where the player is being created. Let player object new, and now we're doing this 0 0 because it doesn't matter. Wait, wrong one. 0 0 because it doesn't matter, and then and mute objects 0 exactly like I did it in make map. Yep, exactly like I did it already. Cool. So I got ahead of myself in a good way because I did exactly what they wanted. Okay, so we're good. So again, take a look at it here. If we did not fail, there are no intersections. So we do create room. We get the center of the new room. And then if rooms is empty, which right now it's every room is empty. Our rooms is always empty right now, the way we're doing it. We're going to fix that in a moment. But if rooms is empty, it's the first room, so set the player's coordinates. And then they're just showing what I did in main, where we set the player to 0, 0, and then we pass the player in the map. So I've already done that. So we're good there. And this is what threw me off. In main, get the starting position from make map. We're not doing that. And use it to set the player's initial. I feel like there's a couple typos here and there. So I'll do my best to address those when we come across them. We're not getting the starting position from make map. Make map is what's setting the starting position. So a little awkward there. So now let's get back to our dungeon generator and make sure we add tunnels between the rooms. For every room except the first one, we connect it to the previous one. Now, sometimes we can't connect them with a straight line, horizontal or vertical, but we need 2 tunnels. We could start with a horizontal tunnel to reach the same level as a new room and connect it with the vertical one, or we could do the opposite. Start with a vertical tunnel and finish with a horizontal one. Both approaches are valid, so we'll choose between them randomly. That's fun, right? Let's see. Let's go back over here. And where do we want to put that? We'll do that. We want to do that on the... Yeah, this is right down here. Okay. I was going to say, it's good. It's got to be if not failed. So we do it on the tail end of if rooms is empty. Else, then it's the second room. So we start channeling back now. So all rooms after the foist, connect it to the previous room with a tunnel. Center coordinates of the previous room. Let prev x, prev y equal rooms, rooms.len -1 dot center. Toss a coin. Oops, toss a coin. Random bool value, either true or false. If random. I didn't know you could just do that to get a boolean. That's nice. Oh no, it's generic, so it just figures it out. That's sexy. I like that. It returns a T, so it figures out automatically, since we're putting in an if statement, that it needs to be a boolean. All right, so first move horizontally, then vertically. Create H tunnel, and that's going to be prev x, new x, prev y, mute map, okay. Create V tunnel, prev y, new y, x. All right, and we just basically flip these. Is there any difference? Pre-y, new y, prev-x. Oh, it's a little bit different, yeah. First move vertically. Yeah. Then horizontally. Create V tunnel. Prev y, new y, prev x. Alrighty. Finally, the last thing we do in if not failed is push the new room in there. So that room's Vec is finally like, oh, it's a rectangle. Okay, I know what's in there now. Although we kind of figured it out a long time ago when we did room. No, I don't think we did actually. If I get rid of that, is it still not sure what that is? No, it's figured it out. Somewhere where the way we're using rooms, Oh, that's where. Okay, that's where we did it. Because we used it there and it had the intersect method. Okay, cool. Alrighty. So, and there we have it, a procedural dungeon generator. Oops, why did I do that? It's fine. So yeah, how does this thing work? Let's try to break it down a little bit. So if we, in this case, we want to move horizontal first. So we go from the previous X center to the new X center. And in the previous Y, what is, I gotta look at the H tunnel and stuff again. How is that, I think I was on the wrong thing, that's fine. So, let's take a look at that third one there. Oh, that, okay, yeah, that's it. Okay, yeah. So from the previous X to the new X, and we just stay at the same Y value the whole time. That's what that previous Y is. So we take the center of the previous room, we go over, and then we take the Y value from the center of the previous room, and we go up to the new one, keeping X the same from the new value. Okay, yeah, that makes sense. And we just do the same thing in kind of in reverse order here. We got to start from the center of the room and move vertically and then over. Okay, that makes sense. So cargo, run, release. What do we have? Does it work? Does it work? Did I break it? Oh, I didn't break it. We got us a dungeon. It's a working dungeon. Okay. And we can't go through the walls. So I'm forced to go through the actual hallways and stuff. We got us a bit of an interesting little setup here. We got a lot of extra intersections with the way the tunnels are lining up, so it actually makes it look a little bit more, I don't know if random is a word, but a little bit less like, it's not just one connection between each room. Sometimes you have multiple things tunneling through the same room, or right here we have an intersection between two different tunnels. So it's a little interesting to look at, even though we didn't really do that much work. We now have a dungeon. So again, that's exciting to me. I like that. A lot of fun. And that's the end of section 3, I believe, right? Let's check it out. Let's see. Yep, there we have it, a procedural dungeon generator. Here's a complete code. Then it's on to the next part. It's been 2 hours and 42 minutes, 43 minutes really. Yeah, 43 now on the dot. I think we can do this. I'll keep going. So this will be part 4, field of view and exploration. This is a little bit shorter than the last part it looked like. There's a lot of code, so it's going to be fun. But, I mean, look, there's a lot of constants here. That's going to be easy. So it shouldn't be too bad. Field of view. The next step towards a complete roguelike is FOV. This adds a tactical element and lets the player wonder what's on the other side of every door and every corner. The FOV works like a light source where the player stands, casting light in every direction but not getting past any walls. Regions in shadow are invisible. You could code it yourself by casting rays outward from the player, but it's much easier than that. libtcod has a whole module dedicated to it. It includes different methods with varying levels of precision, speed, and other interesting properties. There's an excellent study here if you want to know more about them, including tables and images comparing the different algorithms. Well, let's take a detour and look at it real quick. Yeah, so what we can see here is like the way these different algorithms behave around a pillar. So we have basic, we have the shadow, we have diamond, digital, corner peeking. So you have different ways that it looks when you're peeking around corners and stuff. Diagonal walls. Yeah, so there's a lot of interesting information to be gleaned from that, but we're not going to go into it right now. Okay, so anyway, tables and images, comparing the algorithms. All right. We'll define the chosen algorithm along with some other constraints so they can be changed later. For now, we'll just use the default basic algorithm. There's also an option to light walls or not. This is a matter of preference. Another important constant is the maximum radius for FOV calculations, how far the player can see in the dungeon. Whether this is due to the player's sight range or the light from the player's torch depends on how you choose to explain this to the player. Alrighty, so let's start implementing. So the first thing we need to do is add some of those constants. So we're going to go back up to the top here, and you should be seeing the code. So const FOV algo, FOV algorithm, equal FOV algorithm basic, default FOV algorithm, const FOV light walls, bool equal true, light walls or not, const torch radius by 32 equal 10. And we need to add colors for the lit tiles. So const color dark wall. Oh wait, that's what we already have, right? So let's not redefine that. It's already there. So we have dark wall. We have light. We don't have light wall, so let's add light wall. What is a light wall? R130 and G110 and B50. Right? Yeah. And we have dark ground 50, 50, 150. And then we're going to have light ground. Color light ground. 200, G is 180, and B is 50. We like that 50 value there, don't we? Alrighty. So let's click back over here. The FOV map object in tcod is called map, which conflicts with our own dungeon map type, so we'll rename tcods to FOV map on import. Because why not, right? Okay, I'll accept it. So we're gonna go ahead and add FOV map to our struct. So we got a couple things to do there. Bring tcod map, type in and alias it to FOV map, and add that to the tcod struct. And then we'll need to create it as well when we're actually making our tcod struct. When we're doing let mute tcod equal tcod, we'll have to make an FOV map here. So initialize con and initialize FOV. So let's do both of those, or all of that, basically do the import and stuff, and then move on. So do I already have any other tcod stuff? I do, but yeah, we can put it in here. FOV algorithm map as FOV map. And then where is, there it is, there's tcod. FOV is an FOV map. Boom. And then, well, it's already complaining. We could see it right there. Am I on the right? Okay, good. I keep checking to make sure I'm on the right thing so you can see the code. So then they said initialize con inline. So that's one of the new things they did. So instead of this here, I did con like this. And then map is FOV map new, map width, map height. Why are you mad? Oh, it's FOV, not map. Duh. Sweet. Alrighty. Simple. So initialize con and initialize FOV, both inline there. The libtcod FOV module needs to know which tiles block sight. So we create a map that libtcod can understand and fill it with the appropriate values from the tile's own block sight and blocked properties. Well, actually only block sight will be used. The blocked value is completely irrelevant for FOV. It'll be useful only for the pathfinding module, but it doesn't hurt to provide that value anyway. Okay. Also, libtcod asks for values that are the opposite of what we defined, so we toggle them with the negation operator. This goes in the main function before entering the main game loop. Okay. I guess libtcod says you can see through it, true or not, and we're saying, does it block true or not? So saying you can see through it's a positive, yes, versus what we have right now is a blocked positive means that you cannot see through. I don't know if that makes sense. So right here, we're going to populate the FOV map according to the generated map. So for y in 0 to map height, for x in 0 to map width, tcod.fov.set x, y, not game.map, x as usize, y as usize, block site, not game.map, x as usize, y as usize, got blocked. That's messy, let's do that. So whether it's transparent or walkable, that's what we're saying. Okay. So that's why we provide both. Got it. I was curious why we're providing both and what the function parameters actually mean, but one of them is transparent, one of them is walkable. Okay, that makes enough sense, and that's why it's useful for pathfinding. Easy enough. Okay, got it. So we just loop through every tile in the game and add that information to the FOV. FOV needs to be recomputed, but only if the player moves or a tile changes. To that end, we'll keep track of player's position from the previous run of the game loop and compare it to the current position. Add this before the main game loop. Okay, so let's do it. Force FOV recompute for the first time through the game loop. Let mute previous player position equal -1, -1. Okay. I understand why they're doing that already. Basically, we know that that's not going to be our actual position, so when we check, it's going to be wrong. We're using -1, -1 to make sure FOV gets computed on the first time through the loop. Then this right before handle keys, which is where the player's position could change. Previous player position equal player x dot player y. Yeah, and lastly, replace the existing call to render all with these two lines. Okay, so let's go ahead and get that. I feel like a lot of stuff is stacking up, even though it's not. Okay, so handle keys is where it could change, right? So previous, oh, I typoed it. Previous Pallier position. Okay, we fixed that. Previous player position equal player.x, player.y. And yeah, replace the existing call to render all with these two lines. Well, where is render all? Right here. Okay, so what are we doing? Render the screen. Let FOV recompute equal previous player position, not equal objects .x objects 0.y. Cool. And then render all, we're going to add FOV recompute as a Boolean, and it's mute tcod game objects, everything else there is fine. So now it's mad. We're going to see how we fix that here in a moment, I'm sure. Let's see. So now, yeah, okay. Now we need to change the rendering code to actually recompute the FOV and display the result. First, update the function definition to accept FOV map and FOV recompute. No, I think they made a couple of mistakes how they re-architected it, because no, FOV map is inside of game. We don't have to change the definition to accept that, but we do have to accept FOV recompute as a bool. So we're going to do that. Next, recompute the FOV map if the caller asked for it. So let's go ahead and do all that. That's the render all function, but I can also just I can just go to it from here. Go to definition. Let's see, FOV recompute bool. Alrighty, and then what do we need to do in here? We're going to recompute the FOV map if the caller asked for it. So I guess first thing I'm going to do here is, I don't know if it matters. Like we probably want to determine whether we draw objects or not. Yeah, so it is going to affect how we draw objects. They're doing that later though. So let's do it first thing. It's like we don't want to draw things if they're not in the FOV. If FOV recompute FOV if needed, player moved or something. Let player equal and objects 0 tcod.fov .compute FOV player.x player.y and torch radius light walls FOV light walls and then FOV algo. As you can see, yeah, so let's just click in here real quick. As you can see, we're using all the constants we defined earlier. We'll extend the code that render the tiles so that if they are in the FOV, they'll get their light colors. All right. So here it is. Let wall game map. Okay, so we still do all the same stuff, but now we need to ask if it's visible, right? So let visible equal tcod.fov is in FOV with the X and Y values. That just is a yes or no, right? It's true or false. We still get the wall. Everything's the same on that. We also get the color. Color equal match visible wall outside of field of view, false true, color dark wall, false false, color, wait, why did that do light? Color dark ground. Okay. And then there's going to be two other options. We're basically doing exhaustive matching here. Inside FOV. True, true. Again, we need to think about what we're matching here. I'll explain it in a moment. Because I understand, but I'm not taking time to mentally process what these represent. So I can understand somebody watching being like, I don't know what these things are you just put. So let's take a moment to break down this match and how this gets us the color that we want. So we have two options here. We have whether something's visible and whether something is a wall or not, whether it's, you know, passable, whether it's a wall. So those two things make up both components of the four colors we have, right? So this match statement, the first true false is whether it's visible or not. So if it's false, we're outside the FOV. If it's true, we're in the FOV. And then the second true or false is whether or not it's a wall. So then that determines whether we use wall or ground. So these first two need to be dark, and then we determine whether it's wall or ground. And these need to be light, wall, or ground. So that's all we're doing there. And then we don't need to set we don't need to set any of that stuff anymore with the if else's, because that match statement did the stuff for us. So now it just gets to draw for us. That's cool. And we just put color in here. Yeah, we just get to do that, and it draws what we need automatically. Well, not really, but yes. Okay, so next up, we're already more than halfway done. I like it. We've replaced our if with a match, as we've added another check whether a tile is visible or not. We would have to use nested ifs and end up with 4 separate calls to set Carve background. But since the only thing we're changing is the color, we'll just pattern match to get the right value and use it. I partially disagree with that. You could do nested ifs to kind of determine, you could set the color using ifs and then do a single call. You don't necessarily, I mean, I appreciate the sentiment. Matches are way sexier than ifs, but just to be fair, you could do that with ifs without doing 4 separate calls. At least I don't see why you couldn't. Whatever though. Finally, but since the only thing we're changing is the color, we'll just pattern match to get the right value and use it. Finally, we'll make sure we render only objects that are in the player's FOV. Wrap the object.draw call and render all in an FOV check. It's going to be the same thing we just did with if in FOV, basically. So I'm going to move this down below just to kind of mirror the way they're doing it at the moment. Right here. And we want to wrap it in a for loop. Or no, we want to wrap this in an if. If tcod.fov is in FOV object.x object.y, then we do it. We draw it. We've shuffled a lot of code around, but we haven't changed much conceptually. Just track whether the player moved, update FOV and render the map that they did, use lit versus dark colors, and only render visible objects. And look how much better it looks now. Well, I don't know. We want to see how much better it looks? Let's see how much better it looks. Let's see our map with an FOV. Watch it. Oh my God, it's so sexy. It's so good. Look at this. It follows us around. Watch as we go around the corner, we can see more into the room. Look at this. The room is filling up because we can see the entirety of the room now. Right? I like it. I like it. This is like our torch lighting the place up, right? Representing what we can see. Good stuff, yeah? I just want to go to this room way over here. Watch this. Zoop. Fun. Big fan of that. We can even see how it fans into the room here. As you would kind of expect light to do. Cool, right? Fun stuff. Now, we're not done yet, but we're actually almost done with the 4 chapters that I wanted to go through here. So let's check it out. The last detail after FOV is exploration, aka fog of war. You've made it this far, so this will be a piece of cake. What you may say, fog of war can't possibly be the easiest thing. All right, we'll try that again. We'll give it the right emphasis. What? You may say fog of war can't possibly be the easiest thing to code in a roguelike. Well, it is. Wait and see. First, all tiles will store whether they're explored or not. They start unexplored. Put this in the definition of the tile struct. Womp, womp, womp. We gotta change a struct. It's gonna bubble up through all the code. It's gonna be terrible. Not really. It's not gonna be that bad. So they put it in the second one. It doesn't really matter, but I'm gonna mirror what they do. Explored bool. And then you need to update tile empty and tile wall bodies. So explored false. So obviously nothing starts explored. So boom. And then in render all, after the visible wall match, make sure they are all visible tiles are explored and only render those that are. Okay, so let me do this as well. So render all. Okay. After the visible wall match, make sure the visible tiles are explored and only. Okay, yeah. So we're going to say let explored equal and mute game.map x as usize, y as usize dot explored. If visible, since it's visible, explore it. Explored equal true. Explored, excuse me. And we gotta make it mutable now. And mute game. That's gonna bubble down here. I'm jumping a little bit ahead, but I want it to stop yelling at me. Cannot borrow game is mutable because we didn't make it mutable. No, we're good. Okay. We're going to go through this in the tutorial as well. It's going to explain all that. So if that was a lot of me jumping around, don't worry about it. You'll see it in a moment. Okay. So if a tile is visible, okay. So what we're doing here, we're getting a mutable reference to the explored property of the current tile. And then if the tile is visible, we set explored to true. Now, does it matter? No, but I mean, you don't really need to waste time checking if it's explored. It's not that big of a deal, but you are going to be setting the same tile explored over and over. So I don't know, it's not a big deal for something like this though. So if explored, notice we're having to do the star here. We're dereferencing it because we have a reference. So if star explored, show explored tiles only, any visible tile is explored already. tcod.con. It's actually the same thing. Let's just copy that and plop it in here. Yoink and a yoink. If the tile's explored, do it. Just do it. Okay. So this gets us two cool things here. So let's go break down a lot of this. I'm going to reread a lot of what I just did, just to make sure we follow along. So we went into this tile struct and added the explored field. Easy. Then in the impl block, we have two functions making tiles. So we had to add false on for explored for both of those because you don't start out having explored the map. Then in the render all function, after the match, we get that reference I just described, the mutable reference to the explored property of the current tile. If the tile is visible, which is still left over from that match block, we already determined whether it's visible or not, from right before that match block, I should say. If it's visible, then we set the tile to be explored. And if the tile is explored, then we draw the tile with the color that we already determined and everything. Easy. So that actually has the benefit of drawing maps that are not visible, but explored. It actually works for that case where we'll still get the dark color because it's not visible, but we have explored it. So we'll see that in action in a minute. So yeah, it says we take a mutable reference to the explored field so we don't have to write full map as usize y blah blah dot explored bit twice. And finally, since we're now actually modifying the map, we'll need to pass a mutable reference to render all. Since map is carried into the game struct, we need to make the game variable mutable. And I just did all that too. So let mute game equal game, and then we make the map. And then we pass a mutable reference to game, of game, it should say. A mutable oh no, that's right, never mind. A mutable reference to game to render all. Render the screen, yep. Let FOV recompute. And you can see here is where they change it to end mute game. Game is now end mute. And last, the render all function definition also needed to be changed to an end mute game. And that's, as you saw, like the first thing I did. They kind of went in the opposite order that I did. I see the errors as I'm writing, and it unravels the other way. So the first thing it complained about was that game was not mutable as I was writing in the render all function. So I made it mutable here. But then that means where I called render all, it's complaining because I'm not passing a mutable reference. But I make that mutable, then it's complaining that this is not mutable. So I kind of went in the reverse order of the way they described it, because I like the conversation with the compiler, and my VS Code extensions, the error lens extension allows me to see that error in real time. That's what the red error is in the middle of my code. So I really like that because it allows me to know right when something goes wrong. And it's immediate feedback rather than compiling first. So anyway, and that's that. If you run the game now, you start in mostly black space except for your immediate surroundings, and the map fills in as you explore. One might argue that the render all should not actually modify anything and that FOV/exploration code belongs somewhere else. They wouldn't necessarily be wrong, but let's just roll with it for now. Okay, so the moment of truth. We're going to stop at the end of this part. We're actually only 3 hours, and I thought this was going to go longer. We're only 3 hours and 11 and a half minutes in. I thought with the length of the other parts, this was going to go longer, but the FOV stuff was pretty straightforward. It wasn't actually as long as it seemed like it was going to be. So, the moment of truth. We have completed 4 parts today, and let's see the result that we have at the end of the 4th part. Boom. Oh, whoops, my bad. I wasn't in the code. No, it spoiled it. Not really, it's still fine. You didn't miss anything anyway. You missed it booting up. But there we are. This is it. We have a procedurally, or rather randomly generated dungeon. Every time, different dungeon. We have an FOV system where we can walk through the dungeon, and we're about to see this in action. The dungeon will light up as we walk through it. We'll uncover more of it, and the places we've been will stay in our memory, if you will. You could describe it like it's in our memory. So they'll be dark. They won't be lit up, but they'll actually still be on the screen. And we can just uncover the entirety of the map if we want. And so we're just like hanging out in this hallway. We're chilling. We got another hallway here. It's good stuff. There's no enemies, you know, there's no NPCs really, except for that random rogue @ sign that still hangs out, but you know, it is what it is, right? I should be able to uncover that if it's not. Oh, there he is, yeah. Now, we don't remember that @ sign is being explored or not, but it's okay, right? So yeah, we can now roam around this map. I personally think this is really exciting. I would hope that if you are watching me and you're over 3 hours into this, that you do too, because this is like the very solid foundation of a little dungeon crawler roguelike. I mean, you can't really go wrong with this kind of start, but you do want to be careful, as was mentioned in the tutorial itself. All the games that are made directly from this tutorial can feel a bit samey if you don't take the time to really differentiate your game from the tutorial. So it's like, don't just take this code and change the item names or whatever and be like, oh, I made a roguelike. No. You want to do game design on top of this foundation and really make it yours, make it unique. So, here we go. But I want to see, what if it's like really short? What is the next part? We got to at least get a preview of the next part. No, the next part is way longer. The next part, oh, this is a good cliffhanger right here. This is the perfect cliffhanger. It's gonna be painful for me because today's Wednesday. I do Monday and Wednesday coding streams. I won't be doing this until Monday. So that's a long wait. But yes, We are going to be starting from chapter 5 next time, preparing for combat, where we are going to be populating the dungeon, adding monsters, a lot of fun stuff there. I'm excited for that. Let's go ahead and overview all the chapters. So we've done 4 chapters. We've done basic graphics, objects and map, the dungeon, field of view and exploration. So next time we're going to do preparing for combat, going berserk, the GUI, items and inventory. We'll target doing 4 of them, maybe 5. And then we're going to also have spells and ranged combat, main menu and saving, dungeon levels and character progression, monster and item progression, and adventure gear. So we're going to have probably 2 more sessions. I'll cram 5 parts into 1 session. So then this will get me through the entirety of next week's coding streams as well. And just because it's really fun, and I think it's a good thing to like really bask in this progress at the end of the stream. Here we go. A brand new dungeon has been generated, and we can like just explore. We can walk around. We can explore it and uncover it. Like, it's so cool, right? And it didn't take that long to make this. Looks like, you know, something that you would just expect to see in a simple roguelike. You know, you're playing NetHack or something. NetHack doesn't work quite like this, but the idea is there, right? This looks like something you would expect to see in some kind of a classic ASCII-based or text-based roguelike. And here we are. This is it. We got a dungeon. We light it up. We explore it. It's so cool. Again, I want to really bask in and enjoy that progress at the end of the stream, because it's really like it feels like a payout, right, for the time and effort that was put in. It's the payout. So yeah, I just want to finish doing this real quick because it's going to bother me if I don't. I got to uncover the whole map. What do we got over here? See, but this is cool because like you never know what's around the corner because the randomness, right? Even though there's nothing to do in the map, the randomness is already exciting because you don't know what the map's going to look like. So it's already interesting. So there's the potential already showing through, right? Let me get right here. Well, let me find a good spot I like. Yeah. That looks cool. Okay, so that's going to be it for today's coding stream. Let me get the proper name of the tutorial real quick. I don't want to do the person dirty. Tomas Sedovic. I'm not sure. But the Roguelike tutorial in Rust plus tcod. That is it for my first coding stream of that. And there, as I said, there will likely be 2 more. That's what I'm aiming for. We'll do like 4 or 5 next time, and then 4 or 5, whatever's remaining, the time after that. And then once I finish this tutorial, we're going to go to the more hardcore one. So the idea, I explained it already, but let's take a look at what we've seen with libtcod here. FOV was completely done for us with libtcod. Excuse me, sorry. But FOV, libtcod did all that. We just handed libtcod a couple values and said, hey, do the FOV for us, and it does. Like, we had to work with it a little bit, sure. We had to define the colors and stuff and then match against what we get back from the FOV map. We have to update the FOV map, but like 95+% of the work for FOV is done by libtcod basically for free. Like, we barely have to do anything. The other tutorial that I'm going to be starting after we finish this one is much more in depth and will actually have us doing those algorithms ourselves. That to me is what I'm really excited for, because I always say, like, I like to spend time learning how something works under the hood, because that gives me a better idea of how to use it in the future. It gives me a true understanding of how it works and how I can actually use it. So that's not to say anything bad about this tutorial. Again, I want to be clear. I would not do this if I didn't think it was worth it. So just keep that in mind, okay? But I'm really excited to go into that like way more in-depth one and just really get to delve into the nitty-gritty of this. I think that will make me a better developer. I think I'll learn a lot from it. So I'm really excited for it. But that's not today. That's not next time. That's not the time after. So let's not get ahead of ourselves. Again, this marks the end of part one of this one. Sorry, my nose bothering me. This marks the end of part one of this one. So I hope that you enjoyed this. I hope you enjoy the progress so far. This is something that I think is definitely worth doing if you at all have any interest in this kind of stuff. It's pretty easy to follow along with. There's a couple parts here and there that I had to jump in and be like, I understand this because this is what I do, but I think there are a couple things that might lose a beginner a little bit. But it's nice that they have the links to say, like, here's the code up until now. So if you do get lost there's good references there that you can at least see the code and compare. But I think even still, like, this has been fun, and it's proving helpful to get myself back in this mindset. To get myself back into the mindset of like how you might do something like this. Just giving me ideas. I don't know. Like I enjoy it though. I think there's promise. That's all I'm trying to say. I'm rambling a bit though. A lot. So thank you everyone who tuned in, whether on stream or on YouTube. So go ahead and do all that fun stuff. Like drop me the follow on Twitch if you want to see more of this. On YouTube, go ahead and do all that fun YouTube stuff. Click that like button, kick that subscribe button, notification bell, leave me a comment. Definitely feedback. Like that's one of the most important things with programming is constructive feedback. I mean, in this case, I think there was one part I went off on a bad tangent with the copy clone, and I was like, I feel like an idiot. And it's like I did know that, but I completely blanked and forgot, and I was like, I feel like an idiot. But I mean, really, for the most part, this following a tutorial, it's hard to really give feedback on that because this isn't my work per se. But definitely just like feedback, constructive feedback, criticism, all that good stuff. Definitely appreciated and welcomed, especially when I get back to more of my own code. That's where I think it would benefit the most, of course. But I hope this was enjoyable to some degree. And fun or whatever, I don't know. Until next time, have a good day, have a good night, whatever it is, wherever you're at, take it easy.
Raiden, what's your status?
Colonel, I've got Emma Emmerich here. We've managed to avoid drowning.
Good job.